Hey, what's up everyone and welcome to Spring Boot Masterclass or Spring Boot Complete Boot Camp by Daily Code Buffer. So in this particular video, we are going to have a lot of fun and we are going to learn a lot of things. So let's see what we are going to learn today. So what we are going to cover in this particular entire Spring Boot Masterclass is, these are the topics that will be what's and whys of Spring Framework. We will be going through the all of Spring Boot, how to start with the Spring Boot and how to go ahead with all the Spring Boot components and how to create all the different REST APIs, all the different methods, how to create the entire application with the help of Spring Boot. We are going to also learn about the JUnit and Mockito, how to create the unit testings, how to write the unit testings for all the different components that we are going to build. So we are going to build controller layers, service layer, repository layers. For all those type of components, we are going to learn how to create the test cases, and also we are going to learn how to write a integrated test as well using JUnit and Mockito. We are also going to learn Spring Data JPA, and with that, we are going to use the MySQL database, and we are also going to use the H2 in-memory database. We will see how both can be used, and we are going to see how the Spring Data JPA gives us the ease to create different queries and how to interact with the database from your Spring Boot application. And we are also going to learn about the Spring Security. We will be implementing the entire Spring Security within our Spring Boot application, and we are going to also implement the authorizations, authorization server, authorization client, resources with Auth2 and OpenID Connect. So this is going to be a jam-packed course. Let's also see what are the different topics that we are going to cover for each and every topics that we have mentioned. So for what's and whys of Spring, we are going to learn about what is Spring Framework. You need to understand the foundation of Spring Framework. And we are also going to see what are the advantages of the Spring Framework and what is the life cycle of a bean, how your beans are created, how you define the dependency injection in the Spring Framework, and what is the Spring AOP, that is the aspect oriented programming. So these are the very core concepts of a Spring Framework which will help you to learn more on the Spring Boot. So these are all the concepts that are being used in the Spring Boot. So once you grab all these concepts, it will be very easy for you to grab the Spring Boot framework, because once you understand all these concepts and then you switch to Spring Boot to start learning Spring Boot, you will get the aha moment. Okay, these are the lot of things that I don't have to do. Okay, because these are already done by the auto configuration of Spring Boot. So you will be able to understand a lot of things in detail. Now within the Spring Boot module, what we are going to learn is what is Spring Boot, why Spring Boot came into existence, what are the advantages it gives to a developer, how developer friendly the Spring Boot framework is, and we are going to see how to build our REST APIs using Spring Boot framework. So we will be creating all the different APIs to create the data, update the data, to get the data, to get all the data. Seems like a complete CRUD application where these are the general operations you will do in your day-to-day work. So we will be seeing all those things in detail, and we are going to write the unit test cases for each and everything that we develop. So we are going to write a unit test case using JUnit and Mockito for our controller layer, for our service layer, for our repository layer, everything. And we are also going to write the integration test as well to test out each and every component together. So in the Spring Data module, we are going to learn about the JPA, that is the Java Persistence API, and we are going to learn about how Spring Data JPA uses that JPA and how it uses the Hibernate and give us the lot of different functionalities to directly interact with the database. So there are a lot of features that are directly built into the API which we can directly use, and if you want to enhance, we can also enhance all those APIs. We can write our own custom queries and everything. So that's when we are going to also learn about the Hibernate as well. And we are also going to learn about the different entity relationships in the Hibernate. We are going to learn about the one-to-one relationship. We are going to learn about the one-to-many relationship, many-to-many relationships, unidirectional relationships, bidirectional relationships, and all of those things. Then we are going to learn about the Spring Security, which is a very important part. And this is where every developer feels little bit hesitated to learn, because at the starting it feels little bit complex, but once you understand the concepts, once you understand the all the jargons that are being used, it is very easy to implement. So we are going to learn about the Spring Security, how to implement Spring Security in your Spring Boot project. And we are also going to learn about the Auth 2.0 and OpenID Connect. What is Auth 2.0 and how we can implement that in our project. And we are going to see a complete flow in which we will include registering a user with a verification code, resend a verification code, forgot password, reset password, and a complete login flow with the help of Auth 2.0. And This will all be implemented using a token-based authentication, which will allow us to create the different resource servers. These are the concepts available in your Auth 2.0. So we'll be creating resource servers, we'll be creating clients, we will be creating authorization servers. So all this will connect together and you can create your application. So these are the things that we are going to learn in our entire Spring Boot masterclass. Now to get the most out of this course, these are the prerequisites that you should know. That is the Java. You should be familiar with the Java programming because we'll be coding everything in Java. I will be teaching you each and everything about the Spring and Spring Boot, but the basic syntax of Java, how to create a Java program, all you should know. These are the basic things. And if you know the basics of Servlet, that's the advantage. But we will be going through each and everything in this tutorial. And the main important thing, you should be having the enthusiasm to learn all these things because this is going to be a very long masterclass. You should be going through each and every topics in detail. And while we are doing the coding, you should also practice alongside. It should not be like you just go through the tutorial and you don't practice it. You have to practice it and then only you will be able to understand each and every concepts. Then what are the software requirements? So you should be having Java installed. I'll be using Java 11 in the entire course. So if you use that, it will be very easy for you to follow, but you can use any Java version. Make sure that you are using Java compatible with your IDE that you are using. I'll be using the IntelliJ IDEA ID. You can use IntelliJ IDEA if you want. That's a community edition which is free of cost that you can use for learning purposes. There is Eclipse as well, Spring Tool Suite as well. You can use anything. You can use VS Code as well, and you can install all the different plugins available to support the Java project. And I'll be using Maven 3 Plus. So Maven 3 Plus you can install and you can configure in your variables. And I'll be using the MySQL database. So you can install MySQL Server and Workbench. So I'll be showing you all those things. So you can install directly, go to Google and you can install all those stuffs and it will be easy for you to follow. And by any means you're not able to install it, then you can let me know in the comment section below, or you can use the H2 in memory database as well. I'll be showing you all those things in the tutorial. So that's all about the course. And if you have any queries, any issues, then you can reach me out to my Twitter handle or Instagram. These are the handles. You can reach me out at Daily Code Buffer on Twitter and Daily Code Buffer on Instagram. You can follow me there. I will be posting a lot of contents there and you can DM me as well. I'll try to help you out. I will try to answer your questions. If not, there is a comment section always. If you have any queries, comment it down and I will try to help you out as soon as possible. So that's it. Grab a cup of your coffee and let's start our masterclass. If you're new around here, welcome to Daily Code Buffer and this is Shabir. I will try to teach you whatever I know and whatever I have learned using this all tutorials. Now first let's see why frameworks first of all, right? So if you're working with any of the programming languages, or in this particular video, let's take the example of Java. Java gives us a lot of features and advantages to build the application. But when we are trying to build the enterprise applications, when you are trying to build the business applications, right, at the time we have to concentrate more on the business logics. At that time we don't have to work around, or we don't want to work with the basic boilerplate codes or the basic necessities or basic cross-cutting concerns, we can say, right? So we'll be doing many things like security, like logging, like configurations, like batch processing, scheduling, many things, right? So these all things directly doing with Java without any frameworks, it will take a lot of time. So frameworks comes into picture at that time. Like frameworks are the way that will provide a lot of basic structure, basic functionalities that we can work upon, and we can mainly concentrate on our business implementation. So Spring is not the first framework. There are a lot of frameworks available for Java, but why Spring is more popular, that we can understand using the advantages of the Spring framework. So Spring is just the another framework like other frameworks available for Java or the other frameworks available for the other programming languages. It gives us a lot of features so we can work upon. It gives us like logging, security, it gives us dependency injections, it gives us scheduling, batch processing, and a lot of things. There are a lot of modules available within the Spring framework. It's a suite of framework, right? It's also called as framework of frameworks. We'll get to that part later, why it's called frameworks of frameworks. But Spring started as a small project and now it's really huge. So let's see the different features of Spring framework first. So the first thing Spring allows us is to inversion of control. What is inversion of control? Inversion of control is nothing but to give the control to the framework itself. You don't have to take the control yourself. You don't have to create every objects or whatever you want to do in your application by yourself, because consider there are thousands of classes that you have created, and for each and every time you are creating the objects and you are destroying the objects for the garbage collection, it's a tedious job. We have to work on the business logic. What we are doing is we are giving the control to the framework itself. Okay, so that is responsible for doing everything. To do that, Spring allows the dependency injection. So we need to understand what is dependency injection. That will cover in detail later on. In a nutshell, dependency injection is nothing but to give the dependencies of different classes into the different classes. Suppose one class needs the object of the other class, then we will give the control to Spring to add those particular dependencies. We won't be adding those dependencies. We will see later how we can do that as well. The other thing Spring provides us is the aspect oriented programming, that is Spring AOP. Now, what is aspect oriented programming? Aspect oriented programming is nothing but to tackle down the cross-cutting concerns, because when you are building the application, there are a lot of things that we might do repeatedly, like logging the user data, whatever the logs we generate, right? Doing logging in, doing securities. So this type of things that we have to do for each and every request that's coming from the server. So to do those things every time, it's a tedious job. So what we do is we separate out all those cross-cutting concerns and we separate out using the Spring AOP, and we define like whenever this particular things are called or whatever the particular methods are invoked, we have to invoke these particular methods or we have to do this particular operations that we will define or that we can define in the Spring AOP. So that's the Spring AOP part that Spring provides us. The other thing that it provides us the ability to create the web application. So there is a Spring project called Spring MVC that allows us to create the web applications. The other thing is, if you want to work with a database, right? So ideally, if you are directly working with Java, you would be working with a JDBC, and we know that working with JDBC is a really tough thing, right? So Spring provides us the Spring data libraries so that we can connect to the database. So for all the different database that you want to use, for all those things, there are Spring Data projects available. Either you want to use with the MySQL, either you want to use with the Oracle or NoSQL databases, anything. For all those things, there is a project from the Spring framework that you can use to connect to your database, and it would be very easy for you to implement those things. And it also allows us to implement other libraries and other frameworks very easily. Suppose if you want to work with the Hibernate for your database connection or for your ORM, then it allows us very easily to implement Hibernate within the Spring framework. So that's why, because of the ease of implementing other libraries and other frameworks in this Spring framework, it is also known as the frameworks of framework. So by all these particular features, we can understand that Spring Boot is a layer on top of the Java to build our applications. Now, as Spring Boot adds a layer on Java for the developers to make the application very fast, reliably, and with a peace of mind, do the same thing with your identity on internet using VPN. With more than 5,200 servers, amazing speed and one-click connect, NordVPN gives us a lot of features and security. As a techie, we know that how much important it is to secure our data and identity. With NordVPN's diskless servers and end-to-end encryption, everything is secure, which routes through the NordVPN servers, so no one will know your IP address. And if you want, you can route through 2 VPN servers to double down on your security and protection. And it also enables all the content on Netflix and Amazon Prime. You just change the server to that particular location and all the contents and your favorite shows will be available to whichever server you have connected to. So I use NordVPN on all my devices. So if you are interested, go to this link or use coupon code DCB to get a 2-year plan plus a huge bonus gift. Check the first link in the description below. Now, to understand more on the dependency injection, let's go to the computer, open IntelliJ IDEA, and I'll show you some code so we can understand more on the dependency injection. So let me just open IntelliJ IDEA. So I'll just create a new project over here and we will use the Spring Framework dependency in it. So let me just create the new project, and you can create Spring project either using Maven or using Gradle. Both are the excellent build tools. So either one, whichever you are comfortable, you can use. I'm more comfortable with the Maven, so I'll go ahead with the Maven. So here you can just select the Maven project that you want to create, because we are not creating Spring Boot project. We are just focusing on the core Spring framework. So from here, select the SDK. I'm using Java 11. So I'm just selecting the Java 11 over here. And there are a lot of archetypes available, Maven archetypes. So from that, you can directly create the base structure of the Maven project. But we are not going from this. We will be creating entire project from scratch. So click on next over here and give the name of the project. I'll just give Spring Framework demo, and in the artifact coordinates you have to give your details over here. Now your group ID is to identify or to get a unique group ID over here. Now we'll add the group ID over here. Generally we will be writing the domain name in the reverse order to make it unique. So I'll just write com.dailycodebuffer, and the artifact ID would be your name of the project. So with the combination of group ID and artifact ID, your artifact would be unique in the world. And then you can give the version as well. We'll go ahead with the 1.0-snapshot version and we'll click on finish. And here you can see that the project is created. So this is the pom.xml file of your Maven. This is very important for your project. So let me just close it for now. Let me go to the src folder, main Java, and let me create the package over here. Let me give demo and let me create the main class over here. Okay, and we'll have the main method as well. Now ideally when we are working with the Java application, what we do is we create a lot of classes, and whenever we want to use those classes, we create the reference of that particular class and we instantiate that class with the new keyword, right? So the object of that particular class is created and we can use that class. We can assign some variables or whatever we want to do, or we can call the methods available in that particular class. So that's how generally is been done in the Java application. So suppose for the example, let me just create one class over here. So what I'm doing is I'm creating a class which says doctor, and let me say public void assist. The doctor can assist the other doctors, and I'm just printing out doctor is assisting. So this is just a simple class that I've created, doctor, and there is one method that is assist, which is printing doctor is assisting. Now if I want to use this, what I'll do in the main class, I'll just create the reference doctor equals to, and then I'll instantiate this particular class with the new keyword, that is new doctor, right? And then I can say doctor dot assist. If I run this should run, right? Completely fine. Now what if I want to create a new doctor again, or what if there are new objects that are to be added to this particular class, right? Because currently if you see there is only one doctor. If you go to this particular doctor class, suppose there are different classes created and the objects of those particular classes are required over here, right? Suppose doctor have qualifications, right? So suppose if you're creating the class qualification and you want to use that particular qualification in this doctor class, what you will do, you will just create a qualification reference to it, and whenever you want to create the object for it, either in the getter setters or in the constructor, you will instantiate this particular object using the new keyword. So that thing is bound to this doctor class, right? Because whenever you want a doctor class, you have to have the qualification class. So you can see that those two class, doctor and qualifications, are tightly coupled, right? Because whenever you need a doctor, you need to have a qualification. Without that particular qualification, you cannot create the doctor, because you have directly instantiated the qualification class within the doctor constructor itself. So this is a particular concern that we have to solve, right? And Spring allows us to solve that particular concern. Now to solve this concern, what we have to do is we have to do the loose coupling. You might have heard this term, right? Tight coupling and loose coupling. So we have to create a loose coupling within the objects that we are creating. So that means if you want to work with directly qualification, you should be able to work. And if you want to directly work with a doctor, you can work. And if qualification is available, that's fine. We can use the qualification. If qualification is not available, we can still create the doctor, right? Ideally, it should not be, right? But here to understand, we can create the object. And the other thing why we have to do the loose coupling is for the unit testing. We will be creating a huge projects, and to test it everything every time is not possible. So what we do, we separate down, or we create a different components, small components, and we try to test those small components. We do the unit testing of those components and we try to build the application. So that means if we create a doctor class over here separately and we create the qualification class also separately, we should be able to test both of them separately, and we should be able to test both of them together also. So that type of thing should be possible, and that's the design principle that we should follow. So to achieve this, to do the loose coupling, dependency injections comes into picture from Spring. So what it allows us to do is we can create the different classes, and we just tell Spring like these are the classes I have. And what Spring will do is Spring will try to reference all the classes. So it will have the graph of reference, right? It will have like this particular object is connected to this particular class. This is a separate class. This is connected to this particular class. So this all reference graph it will have, Spring will have, and it will try to match everything. So you don't have to do anything. So you don't have to use a new keyword to create the objects or anything. We just have to annotate it, or we can do the XML configuration as well, that this particular class might need this or may need this particular object. So we'll just define everything like a blueprint. So we'll just create a blueprint like this is all I need, and Spring will take care of everything, like whenever the objects are there, to creating the objects and to inject all the objects whenever it is required. So everything Spring will take care of. So that is, we are giving the control to the Spring. So that is the inversion of control, and dependency injection is the process that we are doing. So let's understand how to do this dependency injection. There are different ways that we can do dependency injection: constructor based, setter based, and we can do via XML configuration as well, and then we can do via annotation based as well, and we can do via Java configuration as well. So we'll see how we can do via XML configuration, how we can do via annotation based configuration, and how we can do via Java configuration. So let's see how we can do this. So I'll just remove this for now because I don't need this, and let me go to the main class, and I don't need let it keep this way, right? So now to work with the Spring, we need to add the dependency. So to add the dependency, what we have to do is we have to go to the pom.xml file, and here we have to define the dependencies. What all the dependencies that we need, we can define here, and we can add the dependencies. So what I'll do, I will go here and I will add the dependencies. Okay, inside dependencies, I need to add the dependency. So I'll just add the dependency tag. Okay, in this particular dependency, you can see that you have to provide the artifact and the group ID. That too would be unique. So I just want Spring context dependency, and that is the from the group org.spring framework, and the version that I want to use is 5.3.14. Okay, currently Spring Framework 5 is the latest one, and within few months Spring Framework 6 also will get released, but the base will remain the same, right? This tutorial will be applicable at that particular time as well. And once you add this, you can just refresh the Maven dependencies, and Maven will try to get all the dependencies in your local repository. There will be a central repository as well for Maven, and it will try to fetch all the jar files whichever we have defined over here, and it will create the local repositories so it can give you the content from there directly. So this one dependency is created now. Now if I go to this particular main class, so now we need to understand, okay, Spring will create all these particular beans, right? But where? From where to get all these things, right? So what Spring does is, whenever you start the application, Spring will load all the beans and it will store all the beans in the container, right? So we can get all the beans from the container itself. So there are two interfaces available, that is Bean Factory and application context. From that we can try to get all the beans which are loaded, and we can use those particular beans. So we don't have to use the new keyword to get the object, and we can use that particular object. So let's try to understand that. Now what's the difference between Bean Factory and application context? Application context extends Bean Factory, so there are a lot more features within the application context. Now if you want to know the exact differences, you can go to the documentation and you can go through everything, but here we will be using the application context for now. For that I will link the article in the description below. So let me just create the object of application context, and here you can see that it is part of the org.springframework.context package. Okay, and I'll create the context object equals to new, and here you can see that there are a lot of different ways that we can get the Spring context, but here we have to go with the XML based configuration because we will try to use the XML based configuration. So here there is a class called class path XML application context, so we will be using this one, and as we are using class path XML application context, we need to create the XML configuration for it. So let's create the XML for it. So, and that particular XML has to be in the class path. So whatever it would be in the resources folder, it will be in the class path because everything is in the main, right? So let me just create the XML file, and I'll just say it's spring.xml. So we just define the XML version over here, and then we have to define the beans, because whatever the classes or whatever the objects that we'll be creating, all those will be called beans in the Spring. So all the objects are beans, and we can get those particular beans from the Bean Factory or the application context, wherever the container, whatever the container is holding those things. So we need to have beans, but it's XML, it doesn't have the XSD to understand it. So we need to provide the namespace and those particular information in the XML. So what I'll do, I'll just copy paste the details from the documentation, and this particular namespace and everything will depend on the Spring version that you are using. So currently I'm using 5.3.14. Hopefully that's the one, right? Yeah, so accordingly I'll add the beans tag over here. So don't worry, it's very easy to find. If you just Google it, Spring Bean XML, you will get it and you can directly use it. Okay, so this is what I have done. You need to create the beans tag, and within this beans tag we can create the beans. So whatever the classes that we are creating or we will be creating, we can define over here. And this particular context, this particular XML file, we need to provide to our class path. So what I'll do, I'll just provide, this is spring.xml. It's simple thing that we created the context from the spring.xml. So whatever the beans are defined over here, we can get those particular beans from the context. So how we can directly do context.getBeans method. Okay, so from here we can say, okay, I want a bean of type doctor. Simple thing, right? So in this particular factory, whatever the beans are there for the doctor class type, we will get that particular bean and we can use this particular bean. So if you run this, let's see what happens. And it should fail, obviously. You can see that no such bean definition exception, because Spring still doesn't know that I have to create this bean, because we just created the class over here, but we have to define that this class, whatever I've defined, that's a bean that you have to use. So that thing we have to define in the Spring XML itself. So what we will do is we'll create a bean tag, and in this particular bean tag we will say which class we want to use. We want to use demo.doctor. Okay, and for every bean that we define, we need to make it as unique. So we will define the ID. So I'll just define that ID is doctor. So we just define the bean. Now if we go and check, and if we run the application again, it should work, right? You can see we got the bean from the context itself and it is executing. Cool, right? Let's try to create one more object. So what I'll do, I'll just create one more class that says nurse. Okay, and this also has the same method. Let me just copy it from here, and I can say nurse is assisting. Okay, if I go to main over here and if I say I just need nurse over here, and this is also nurse. Okay, so instead of doctor, we'll get the object of nurse, and we got the error because we have not defined the bean. So let's go ahead and define the bean as well. So we'll go to the Spring XML over here, and let me just define one more bean. Bean class equals to demo.nurse, and I'll give the ID as well. ID equals to nurse. Okay, let me run this again, and you can see that it should work. Now if you see over here, we are defining the type over here, right? That I want the class of a type nurse, but instead of that, you can get the values from the ID also that you have provided. If I just say nurse, so here you can see that it will get the data as an object because it doesn't know the type yet. So we can do the casting. Okay, and if we do this way also, then we should also get the object. You can see that it is working completely fine. Now generally this is not the way that we create the applications, right? Because we'll be having the lot of complex structures, right? So let's make it something complex. Let's add the hierarchy. So this nurse and this doctor belongs to the staff of the hospital. So let me just create the staff interface over here. Staff is the interface, and this staff interface has method void assist. Okay, nurse and doctor both implements staff. I'll go to the doctor as well, and doctor also implements staff. Now doctor and nurse both are part of the staff and both have implemented this assist method. And now I have added both these beans also in the Spring context in the XML file. Now if I go to the main.java file, and instead of doctor, I just need the staff to assist. Okay, so what I'll do, I'll just say staff over here, and I want staff to assist. Now instead of this, what I want is I want the object of doctor for now. So I can say doctor.class. Now this doctor.class should be assigned to the staff, and we should be able to call the method. Pretty good, right? Now either from the doctor we can change to nurse as well, and we should be good here. Now you can see here, right? It's pretty simple. We just decouple the entire application. You can see we are not creating the objects. We are not injecting the objects. We are just getting everything from the container itself, Spring container itself. And we define what are the beans that I have in the XML file. Now, if you see, these are just a simple classes. What if we have some properties? So let me go to the doctor class and let's see if I add properties. Private string qualification. And for basic Java class, if there is any properties that we are defining, we'll be having the getters and setters. So let me create the getters and setters for this. Okay, these are the getters and setters created. Now what will happen over here is Spring will try to create the object that is doctor, right? So it will create the object, but it doesn't know that it has a property qualification, right? Or what value to add to the qualification, right? It will try to add the default value that is null. So if you want to do that, we can inject those particular values of the properties from the XML file itself. So if you go over here and if you see, if I want to add some of the properties, that's the setter injection that we are doing. And if I want to add the properties, I can add using the properties tag over here. And you can see that the property is qualification and the value that I want to give is suppose MBBS. Okay. So this is the value of the property that I have provided to the doctor class. So if we go to this particular class and if I let me just change to doctor for now. Okay. And I also need to change to doctor. And if I do s out staff.get qualification, I should get the qualification. You can see that I got the qualification that is MBBS. So the value MBBS was injected via setters from the XML itself. Now suppose what if you want to inject the entire object itself, right? So suppose just for simplicity I'm doing over here. Suppose if you want to add the object of nurse over here, okay? So private nurse. This should not happen, but just for simplicity to understand, I'm just showing you over here that suppose if you need the object of nurse or whatever over here, what you will do over here is you just define over here nurse, okay? And if you want to inject the value of nurse, so you will go to the spring.xml file. You have already defined the bean. You have to define the bean, right? Then only Spring will understand it. So the bean you have defined over here, and here if you are doing with a constructor argument, you can go ahead with the constructor args tag over here. But here we are just adding the properties. We can add properties and it doesn't have the value because we need to add the getter setters over here. So let me just add the getter setters. So now you can see we are getting the nurse over here. So now you can see that in the first one we added the static values because we had a value defined. So we just use the values attribute over here. Here we need to use the ref attribute. So we have to reference the nurse object that we have created over here. So the entire object from here will be injected to this particular doctor class over here, doctor object over here, right? So here you can see that we are just defining the definition like this is what I want. Spring will take care of everything. We are not using any instantiation anywhere like new keyword or whatever is available in the Java, right? Everything is done by Spring. So that's the beauty of Spring framework. So let me just remove it because I don't want it. I just added here to show you that we can use this way as well. Let me go to the doctor. Let me remove this property. If I go back to the Spring XML, if I remove this as well, and if I want to use the constructor based, then I can use using the constructor arguments. And I can give value equals to MBBS. So it will add to the first property. Okay, I need to remove this. Let me just remove this. Go to the main and run this again. We wanted the error and we got it because you can see Spring could not resolve the matching constructor. So yeah, you can see that we have defined like this particular bean of doctor will have a constructor that's have one argument, but we have not created the constructor. So we need to create a constructor. So if you go to the doctor and if we create the constructor, if I say constructor with qualification. This is the constructor created. Now if I go to the main, if I run this, you can see that I should get the value that is MBBS. So this was injected using the constructor injection. The earlier which we saw using the properties was the stator injection. This was using the constructor injection. So these are the two ways that we can use to inject the values to our beans. Now let's try to do with the annotation based configuration. This was the XML based configuration that we did. There is also another way that we can implement this using the annotations. Within the recent Spring frameworks, you will see everywhere that annotations would be used. Now to use the annotation based configuration, what I'll do, I will just comment this beans out because I'll add the annotations for it. And now after commenting, if I go to the main class, okay, I'm just using the doctor for now, and let me go to the doctor class over here, and let me just remove this everything. Okay, just let's try this simple thing first. It has the assist method, and from the main as well, I'll just remove this. Now to use the annotations, we have to mark this as a Spring component. Okay, that's it. So what we are telling Spring is that whatever the class that we have created is the component that you can use to create the beans out of it. That's it, right? If we try to run it again, let's see what happens. And it should fail actually. And here you can see that it failed over here because Spring doesn't know yet, like you just created the class, you defined like it's a component, but where I should search that, right? So we need to define that search here, you will get the components. So we will go to the spring.xml and we have to define that we need to search the base package. So here what I'll do, here I'll define context component scan over here. Okay, like in which base package I want to search. I'll just say that in the demo package every components are there, so search there, whatever the components that you are getting, try to load those components. So we just defined over here, and we have just removed every bean definitions and everything, and we just added the component over here. Now if I go to the main class and if I run this again, I should get the doctor object. You can see we got the doctor object. But if we try to get the nurse object, right, let me try to get the nurse, and this is stuff. And if I run this, you can see that we got the error because Spring doesn't know that nurse is a component yet. It only knows that doctor is a component. If I run this, doctor should come, right? Doctor is coming. So to make nurse also as a component, we can also annotate with @component. That's it. Simple, right? So this is the annotation based configuration. There are a lot of different annotations specific to the specific needs available. You can see it's a stereotype annotation. So there are a lot of different annotations available. So once you explore the different tools or projects in the Spring framework, then you will get to know more about the different annotations also. So you can understand that this is the way that Spring handles the annotation based configuration as well. The other thing is we can handle using the Java configuration as well. So let's try to create the Java configuration. So for Java configuration, we have to create a configuration class. So let me just create the Java class that says bean config. Okay. And this particular bean config, I need to annotate with @configuration. You can see that it's part of the context annotation, and it will try to say Spring that this is the configuration, that whatever the configuration has been defined, we need to act accordingly. Now what I will do, I will here also say the same thing that you say in the XML. So in the XML, whatever currently it is there, right? Currently you can see that we have defined only one thing. This is not the XML. This is the spring.xml, right? Currently we have defined only one thing, that is component scan, where we need to scan the components. The same thing we will define in our bean config. We are not going to define the other beans for now. I'll just say component scan over here, and where to scan. I'll just say base package equals to demo. That's it. Okay, this is a simple thing that we did over here. Now if you go to the main.java file, here instead of class path application context, we need to use this particular configuration that we are using. So let me just comment it out over here, and I'll use the different context. Okay, I'll say application context equals to new. I'll just say annotation config application context, and here I'll define bean config.class. This is the class that defines the configuration for my annotations. So it will refer to this particular bean config class, and it says, okay, this is a configuration class and we need to scan demo as the base package, and whatever the components are there, we need to load those components. That's it. We'll go to the main. We are not using the XML now. We are using the bean config. If you run this, it should work completely fine. And you can see that it's working fine. Now the other thing also that we saw in the XML is when we had not defined this component scan, we had defined the beans, right? So this also we can do using the configuration. So if we go to the bean config, and here for the same thing, what I'll do, I'll just remove this, okay, for now. That I don't want, okay, let it be. What I'll do, I'll just say public method which will return doctor. I'll say this is also doctor, and I'll say return new doctor. So here you can see that I just created the method over here, that is the public doctor, which is returning the new object of the doctor. And you can, and what I'll say, I'll just say this is the bean that you need to load. Okay, so whenever you're loading anything, this is the bean that you need to load. And to make this work, what I'll do, I will remove the component from here. This is not the component now. I'm defining bean myself in the configuration. This is the bean of type doctor that I need. Simple thing, right? And if I go to the main, this should work the same way, because whenever it will try to load the bean configuration, there is a method that has been defined as a bean. So this will be acted as a bean. The new doctor will be created with a default constructor, that whatever I'm defining over here, and it will be available in the container. Let me just run this. It should work. Cool, right? So this is the way that whatever we define in the XML, we can define here as well. The same thing, whatever you did in the XML configuration, like constructor injection, setter injection, everything is the same way. You have to define this way, either with the bean, or you can annotate with the component. Make it as a component and it will be available in the context. Now let's understand about the different scopes available in the Spring Bean. So whenever the Spring is creating the beans, we need to define how those particular beans we want, right? There are 5 different types of scopes available in Spring Bean. By default, all the beans will be created using the singleton scope. So for each and every class, there will be only one single object available in the entire application. So by default, that's the thing that Spring is going to do. But if you want, we can ask for the different types of scope as well. So there are 5 scopes available, that is singleton, prototype, request, session, and global session. The other 3, that is request, session, and global session, are used mainly when there is a web aware context available. So that is when we are implementing the Spring MVC. But we can still go ahead and see the singleton and prototype design patterns and how to define the different scopes of bean in the Spring application. So default is singleton, which will always result into one particular object in the entire application, and prototype is you will get a different object every time when you request the object from the container. Request is used when you need one object or you need a different object for each and every request that you receive in the application. So currently, let's try to see the current scope, that is the singleton scope by default available, and see what it happens. So whenever we do any changes, that changes should reflect to all the particular objects that we get. So here what I'll try to do is I'll go to the doctor class and I'll add the qualification again. And I'll add the get status for it. Okay, and I'll also generate the toString method. Okay, this is the 2 things that I have done over here, that I have added the qualification property, added the get status for it, and I have overridden the toString method over here. And if I go to the main class over here, and let me just say I need a doctor. Okay, let me convert this to doctor and doctor.assist. Okay, that's fine. Now what I'll do, I'll just try to do sout doctor. Okay, and let me run the application. Currently you can see that I'm getting doctor is assisting and I'm getting doctor qualification is null. But before that, let me just set the doctor.set qualification to MBBS. So I just set the MBBS as a qualification and I'm getting the qualification as well. Now after this, let me try to get the object again. So I'll just say doctor1 equals to context dot get bean. I need doctor.class, and I'll do system.out.println doctor1. Simple thing, right? I just took the object doctor over here and then I added the qualification, and after that I'm getting the doctor again from the container. And if I run this again, you should see that I'm getting the same object back, right? I have set the value over here and I'm getting the object back again, because by default is the singleton design pattern implemented for all the beans, scope of the beans. So Spring is creating only one object for the entire application and I'm getting the same object. And if you want to change it, right, so you can go ahead to the doctor class over here and you can write with @scope. Okay, you can define the scope over here and you can see that there is a scope name available, and if you define singleton, then this will be your default scope, that will be singleton. And if you want to change the scope, suppose I want to change the scope of this particular bean to prototype, then I can go ahead and change to prototype. When I change this to prototype, for every time when I try to get the object from the container, I'll get a new object. So if I go to the main again, if I run this, for my second object, I should not get the MBBS, because that should be the new object where MBBS is not set, because in only first object I have set the values. So if I run this, so you can see that we got the MBBS in both the objects because we have not added the component over here. We have to make this as a component. So once I make this as a component, and if I go to the bean config, let me just remove this bean for now. Now everything is coming from the component of a doctor that sets the scope as a prototype. And if I run this again, let me go to the main.java, and then if I run this, I should get MBBS for the first and null for the second. So that means based on the scope that we defined, Spring will create the objects and it will return the objects accordingly from the container. So now we understood how to create the beans, how to define the different scopes. We need to understand the life cycle of a bean as well, and what are the ways that Spring gives us to do any modification in that particular life cycle. So in the Spring life cycle, there are 7 different steps. The first thing is the definition of a bean, that you will define that these are the beans that we need to create, and after that Spring will try to instantiate those beans. So that's the bean creation or the instantiation process, that particular step in the life cycle. After that, it will try to populate the properties. So whatever the ID that you have provided, what are the different scopes that you have provided, or the default values or whatever that you have provided for that particular bean, Spring will try to add those particular or set those particular values. So the next step is the post initialization step. In this step, whatever the aware interfaces that you have implemented, those particular interfaces will be executed, like whatever the custom execution that you want to do in the bean lifecycle, that particular will be executed. So after that, bean would be ready to serve. All the dependencies and everything would be injected and the bean would be ready and would be available in the container. And the next 2 steps are the destruction of the beans. The 6th step is to pre-destroy. So whenever a particular bean is trying to get destroyed, right? So whenever any cleanup is happening, at that time, if you want to execute in custom logic, like to delete some data or to release the connection or or to close the file or anything, at that particular time, you will define your custom implementation in the pre-destroy phase. And then the last step would be bean destroyed. At this particular time, bean will be destroyed from the JVM itself. So this is the Spring Bean lifecycle where all these particular steps have been mentioned and what happens at what particular step. So if you want to do any modification, then how we can do the modification, that we need to understand. So from this diagram, you can see that once the bean definition is been passed, that particular bean will be instantiated, and then after that, it will populate all the properties, and after that, all the aware interfaces which are there, those will be executed. There are different aware interfaces. So the bean name aware would be executed first, then it would be bean factory aware, then application context aware, then pre-initialization bean post processor process will happen, and then initializing beans after property set will be executed. And after that, if there is any custom methods, then those particular custom methods will be executed. And after that, post initialization process will happen, and at that particular time, bean will be ready to use. And when the container shuts down, disposable beans destroy method will be executed, and then any custom method is there and custom destroy method that will be executed, and then the bean will be cleared from the JVM. Now why we need to implement custom methods in the bean lifecycle? Suppose assigning a default values, right? So whenever you want to create any bean, if you want to give some default values like file path or anything, at that time we can use this particular custom methods to inject those values. If you want to open or close the files, or if you want to open a DB connection and close the DB connection when the object is created and destroyed, so at that particular lifecycle points we can create the custom methods and we can create the connection and we can destroy the connection. And if you want to start the threads or destroy the threads at the time of construction and destruction of the beans, for those purpose also we can use this particular custom methods in the bean lifecycle. So these are just the different examples that I have given you. At this particular places, this bean lifecycle can be very handy. So let's see in the code how we can do this. So the first thing we'll do is we will implement one aware interface. Okay. So in the doctor class, what I'll do, I will try to let me use bean name aware. Okay. And for this, I need to implement the method. So let's go ahead and implement the set bean name method. And this is the method. Okay. So what I'll do, I'll just do a out over here. And I'll just say set bean name method is called. Okay, simple thing. Let's go ahead and run this. Let's just comment this out. And you can see that before creating the object, set bean name method was called, and after that doctor is assisting, this particular method was called. Okay, so this way we can implement all the different aware interfaces which are available to modify the behavior of the lifecycle. The other thing also we can do is to use the annotations. So suppose once the object is created, right, at that particular time, if you want to call anything, what we will do, we will create one method public void, and we'll say post construct, and I will say out post construct method is called. Okay, and I need to annotate with @post construct, but that particular annotation is available in the JavaX annotation API, so we need to add the dependency for that. So let me just go ahead and add the dependency. Let's say javax dot annotation API, which is part of javax dot annotation, and the version is 1.3.2. Let me just refresh the maven, and if I go to the doctor again, if I do post construct, now that it is available. If I go to the main, if I run this, I should get it. You can see that the name was called first, and then after that post construct method was called, and after that object was created, and I was able to execute this object. The same way you can go ahead and implement the pre-destroy method as well. So this way you can add the custom method implementation for your bean lifecycle. So this was all about the Spring framework and the dependency injection, what are the different features available, and how we can use Spring framework for our advantages. If you know these basics and if you know these concepts very well, then you will be able to understand any of the libraries available within the Spring ecosystem, because for everything this is the base. So we already learned about the Spring framework, and in this video we are going to learn about the AOP with Spring framework. So first of all, let's understand what is AOP. AOP stands for aspect oriented programming. Now okay, that's the definition, but what exactly it is, right? Aspect oriented programming is just a methodology with which we will create the applications, just like OOP, right? Object oriented programming, we create the application. Similar to that, there is an aspect oriented programming with which we will create our application. Why AOP and what are the benefits? Let's first understand that. So AOP gives us the flexibility to remove the cross-cutting concerns from our application and to separate it out from the main business logic. That's a lot of jargons, right? So let's understand what are cross-cutting concerns and why we need to separate it out. So when we are creating the application, we tend to do a lot of things, right? So suppose let's take the example of a shopping cart, right? So in the shopping cart, what we do is we add the items to the shopping cart which we want to buy, and from that shopping cart, if we want to remove the items, we can remove the items, and after that, that particular shopping cart, we will check out that shopping cart and we will try to order those items which are there in the shopping cart. We will do the payment for that, and we will add the shipping address and payment details and everything. So all these things will happen, and to do all these things, what we generally do is we try to add a lot of different logics to it, right? There will be a lot of business logics also. and there will be a lot of different extra things that we are going to do. Suppose we are going to do the logging for each and every request that is going for the shopping cart. Whatever the actions are performed by the user for that particular request, we are going to log all those data in the loggers so that we can understand when there is an issue what happened to that particular request. So that thing we will do, try to add the loggers. The other thing we will be possibly doing is to handle the authentication and authorization. We will try to see that particular request is authorized and authenticated properly. Whatever the features the user is trying to use, that particular user has all those rights to use that feature or not. So this type of logic also will be going to implement. Then there might be logics to convert the input data, whatever we are getting input data, to sanitize those data, right? So whatever the JSON format or whatever the JSON input that we would be getting it from the request, we would sanitize those data. So these are all the things that we would do every time when we get a request. Either it would be in the payment page, either it would be in the shopping cart, either when adding the data to the shopping cart, while going to the home page, anywhere. This type of things that generally we do. And this is completely different from the business logic that we have, because for each and every operation that we do, business logic will be different. But these are the things that we would generally do. So these are known as cross-cutting concerns. So what aspect-oriented programming tells us that just try to remove those cross-cutting concerns from the main business logic and keep those things as a different place and run it separately. So that means your business logic is completely different and your cross-cutting concerns like logging, authenticating, authorization, you're sanitizing the data and everything are at the different places. So that's what we are going to do, right? To separate out the cross-cutting concerns in this video. So we will be taking one example where we will see what are the different ways that we can do, what are the different methods available, what are the different ways that we can implement it. We would be using the AspectJ library to implement this AOP with Spring Framework. So let's open IntelliJ IDEA and let's see the demo for it. And before that, if you're enjoying this video, then give us a like on this video and subscribe to this channel for awesome new videos. If you want, you can also join this channel by clicking on the join button below and support me. Now let's go to the IntelliJ IDEA. So let me just open the IntelliJ IDEA. And here I'll create the sample Maven project. So let me just create a new project over here. And here I'll just select the Maven. Project SDK is Java 11. I'll click on next. And the name of the project I'll give as, let me just give Spring AOP demo. And in the artifact, let me give com.dailycodebuffer. So this is what you give to make your group ID as unique. And the artifact ID I'll give as the Spring AOP demo. And the version I'll just keep it the same, 1.0-snapshot. And let's just click on finish to generate the project. So here in this pom.xml file, we have to add the dependencies for the AspectJ and the dependencies for the Spring context, because we will be using the AspectJ library and the Spring framework to implement this demo. So let's do that. What we have to do, we just need to add the dependencies tag. Inside dependency, we need to add the dependency. So we will add the dependency. Here I need to add the Spring context from the org.spring framework, and the version I'll add as 5.3.14. So this is the one dependency that I've added. Let's add the other. And if you don't know how to add this particular dependencies tag, don't worry, I'll show you one way as well. You can directly go to the Maven repository and you can search from there and you can add. Okay, so just go to the browser. Okay, and here search for Maven repository. And here you can search everything. Suppose Spring context. So here you will get that this is a Spring context, and you can go here, you can go to the version and you can just copy this details and you can paste in the pom.xml file. Similarly, I just need the AspectJ as well. Okay, AspectJ runtime. So I'll just go here and I'll just take the stable version. Okay, so this is the stable version and I'll just copy this and I'll add in the dependency. Okay, and let me go back and I just need the AspectJ viewer as well. So let me go here, go to the 1.9.7, the same version, copy it and add. Okay, just save it and refresh your Maven project, and all these dependencies will be added in your project. So the process is completed now. Now let's go to the src folder, main java, and here we can create the package. So let me just create a package that says demo. Okay, so let me create the main class over here. I'll just create the java class and says main, and inside this I'll just create the main method. This is simple thing. Okay, now what I'm going to do is I'm going to create one shopping cart class. So let me just create a shopping cart class. And this has a method public void checkout, and I'm just printing out one thing. Okay, checkout method from shopping cart called. I know spellings are wrong, let me just correct it. Okay, so consider that this is a checkout method and it's doing the checkout for your items in the cart. But for simplicity, I have just written one print statement over here which is printing that checkout method for shopping cart is called, considering this is a logic. Okay, now in the Spring we need to create the bean for this shopping cart, so we need to make this as a component, right? And to get this all the components, either we can go with the XML based configuration or we can go with the annotation based configuration. So what we'll do, we'll go with the annotation based configuration with the bean config file. So let me just create a configuration file. I'll create Java class and say bean config, and this bean config, I'll say this is a configuration. Okay, with the configuration annotation. And what I'll do, I'll just enable the component scan, and I'll say base package is equals to demo. So this is my demo as a base package. So whatever the components that I'm going to create, it will scan all those components. It will scan all the components in this base package available. Okay, now if I go to the main, and I can get that from the application context. So I can say application context equals to new annotation config application context. Here I can give bean config dot class. Simple, right? This is the same thing that we did in the Spring framework video. We got the context, and from this particular context we can get the beans. So suppose I want the shopping cart bean, right? So I'll just say shopping cart equals to context dot get bean. Here I'll say I need the bean of type shopping cart dot class, and I can say cart dot checkout. Simple stuff. Let's run this, and it's working fine, right? Checkout method for shopping cart is called. Now if you go here in the shopping cart, generally what you do when you have a lot of logics available, right? You can do logging, right? You will do logging like you have entered into this particular method and you have exited this method. You will do authentication and authorization. You can do sanitization, sanitize the data, right? So these are the general stuffs that we will be doing every time, right? But this is your business logic. So what AOP, as we defined in the earlier, right, is to separate out the cross-cutting concerns. So these are the cross-cutting concerns that we need to separate it out. Now all the cross-cutting concerns that we want to separate it out, that's called an aspect. So this is the aspect, this is the aspect, this is the aspect logging. Okay, so for all these different cross-cutting concerns we can create the different aspects. So let's take an example for logging. Let's create the aspect. So in the demo, let me create a class that says logging aspect. Okay, and whatever the aspect that you have created, that you need to annotate with aspect. Okay, so we annotated with this particular aspect. Now here you can create the different methods that can be executed. Now if you create a method, right, suppose public void logger, suppose you want to add the loggers, and you just added loggers here, right? whatever. Now how the system will get to know, okay, this is the logging aspect and this is something that we have to learn, and from where we have to learn. So this is something that we have to add. So we need to define the point cuts. So this is a point cut, if we can say, okay, like what we have to run, like this is something that we have to run, but we have to define where we have to run. So for that we will be creating the point cuts and at what location we have to run. So wherever the point cuts you're calling, right? Like suppose if you go to the shopping cart and at this point you want to call that particular point cut, that particular method, so this is known as a join point. So it's simple to understand, okay? Just don't get confused with the lot of different jargons like what is point cut, join point, aspect and everything. Simple thing we need to understand is what is something that we want to call and where we want to call. That's it. We just need to define these two things, and that's what we are going to learn in a simple way. So suppose consider this is a method that we have to call at every method before the execution starts. Simple thing, right? So whenever there is any method available, right? Suppose let's consider a simple thing. For this particular checkout method, whenever this checkout method is getting executed, I want to call this logger. Simple, right? So what I can do is I can define the annotation, that is the before annotation. Okay, and in this particular before annotation I can define before calling this method I want to call this method. Simple. So what you're doing is you are just removing whatever code that you might have written from the log for the logging from here to a different altogether aspect. So here I can define the execution. Okay, so in this execution you can define which particular methods that you want to invoke. Okay, so I can say I just want to invoke the method from demo package dot shopping cart dot checkout method, whatever the return type may be. Simple thing. I've just defined like for any return type, whatever the return type, currently it is void, so that's fine. So that's why I have written mention star, and in the demo package shopping cart type, that is the class, in that there is a checkout method. For this particular checkout method I want to call this logger where before calling this method. Okay, now if you could try to run this, still it won't work, because if we can check, it won't work, right? You can see that it didn't work because we need to enable it. So if you go to the configuration bin config, and here we need to enable aspect J auto proxy. So once we define this, and if you go back and run this again, still it didn't work. Because how Spring will know that there is something called aspect? Because Spring just understands what components, right? So let me go to the logging aspect, make sure that this is a component, so it's in the Spring's radar. Okay, because we have defined that whatever is inside the demo package we need it, right? So let's go back to the main class and let's run this again, and now we should get it. You can see that the loggers was called first and then the actual method was called. Okay, so that means you just removed the loggers from the main method, only kept the business logic, and you just removed the loggers to the new aspect that you created, that is the logger aspect. Now there are different point cuts that we can call, right? Suppose currently we called for before, we can call for after, we can call after returning a value, we can call after throwing a value. Okay, and we can also call around the method. So these are the 5 things that you can call a method for. So let me go to the logging aspect again, and let's create for after as well. Okay, I'll just tell this as a before logger, and let's create one more public void after logger, and I'll just say s out after logger, and I'll just say before logger, just to separate it out. And I'll annotate this with after, okay, because I want to call it after, and I want to call around the method. So I'll just define in the execution, and here I'll just define that star for any return type, star for any package, dot star for any class, dot checkout method. Let's run this. Let's go to the main and let's run this. And you can see that it worked because we have defined the logging aspect this way that for any return type, for any package, for any class, if there is a checkout method, then we need to run this particular method. Okay. Now what if I just add any of the input parameters? Suppose I'll just add the input parameter string status. Okay. And now if we try to run this, okay, there is an error. So we need to go to the main class and here I can say status is cancelled, suppose. Okay. And if I run this again, and here you can see that only checkout method for shopping cart was called. So the aspect was not called. So to make sure that the aspect matches the input parameter as well, we need to go to the logging aspect, and here in this particular parenthesis we just need to define 2 dots. So it will just make sure that whatever the number of parameters are there, it will match. Okay. And if I go ahead and run this again, it should work. You can see that it is working completely fine. So we just saw that how to define a particular point cut over here and what are the patterns that we can give for the point cut to match the join point. Now let's define one more aspect because we need to separate out the authentication and authorization as well, right? So let me just create one more Java class that says authentication aspect. Okay. And as we did in the logging aspect, we need to annotate with aspect and we need to annotate with component as well. Now here what we can do is we can create a point cuts, and that point cuts also we can define in the methods to be called. So suppose if you have multiple point cuts, right? So suppose we have multiple different packages available, and for all the different packages we want to do the authentication and authorization. So we can define the different types of point cuts. Like this is the point cut for this particular package, this point cut for this particular package for different packages, and you can call the aspect for all the different types of point cuts. So let's try to do that. I'll create one more method, public void. I'll just say authenticating point cut. Okay, and I'll just say public void authorization point cut. Okay, you can see that I just created 2 point cuts. So rather than directly defining where to call, let me just mark this as a point cut. So I can mark with @point cut annotation. Now here if you see the logging aspect, you can see we use the execution over here. So this execution defines for which particular method that you want to execute. And here in the authenticating aspect, we will define with within. So this will define for which particular type of class that we want to execute for all the methods available. So I just want like whatever the methods available for the shopping cart, I want to execute the authentication. So I can just define for all the demo dot star, simple thing. And for all the types within this particular demo package, I want to execute this authentication point cut. And similarly, this also I want to define within means for your class, your type. Okay. And within the demo package, if you want, you can select the shopping cart. Okay. Dot star for any methods. This way also we can do, and we can give directly dot to make sure that for any of the class. Okay. Let's keep it this way also. So we have one more example for this as well. Now these are the 2 point cuts that we created. Now we need to call these point cuts as well. So what I'll do, I'll just say public void authenticate, and I'll just say SOP sout authenticating the request. Spelling is wrong. Let me just correct it. Okay. So I'm just trying to authenticate the request. Now I need to check where. So I just want to do before. Okay, I want to do before a method is called. When, so here I just want to define like when I want to do the authentication. I want to do authentication before the point cuts that I have mentioned, because first thing I want to do when any request comes is to authenticate that request. So here I'll define that I just need to do authenticate. So whatever the point cut I have defined, right, it will come here at the authentication point cut, authenticating point cut. But I also want at the time of authorizing point cut. So I can define with end operator and authorization point cut. Okay, so I'm just telling for these two, authenticating point cut and authorizing point cut, I want to call this method. If you want, you can also go ahead with or as well. Okay, and you can go with and as well. So either of the whatever the requirements, we can call these particular point cuts this way as well. So let's go ahead and run this. If you go to the main, if you run the method again, and it didn't work. So let me just change to all the type over here and let's run this again. It should work now. And here you can see that it is working, authenticating the request. Okay, so this way we can define for the type as well. And if we have this available in the different packages also, then we can go ahead and add the different packages and we can mix and match the packages with AND condition or conditions. Now these are just the simple things that we did, like how to call the aspects. Now there will be scenarios where we need to get the data as well. So whatever is happening within the shopping method, we might need those details as well. Suppose we need to have the input arguments, we need to have the return variables and everything. So let's try to understand that as well. Suppose for this particular logging aspect, if we can see for the checkout method, we have defined that we might also get the input variable or we might not get as well. And here we have defined that there is an input variable. Now let's see what are the different ways that we can get. And if you want anything to access within this, then we can define the join point over here, join point object. Okay, and from this join point object, you can see we can get many things. What is the kind, what is the signature, source location, static part, what are the two long strings, short strings, arguments, target, this lot of things that we can get for the point cut, whatever we have defined. So let's try to get the signature. Okay, and let me just add this in the sysout. What is the signature of the method that has been called? And if you go ahead and run this, and you can see that the signature is void demo shopping cart dot checkout and the input parameter is string. Okay, so you can see this way we can get the details. Now let's try to get the details of the arguments. So the argument we have passed is type string, and let's try to check what is the value. Suppose if we want the value, right, to log anything, so we can do that way. So in the logging here, what I'll do, let me just comment this out and I can take gp dot get arguments. Okay, so it will return the array of arguments. So we might have multiple arguments, right? So it will return the array, and from that array I just need the first argument because I have only passed one argument, and that argument is type string. So I just want to convert it to toString. So this is my argument that I'm getting, and if I get in this string argument over here before loggers with argument, okay, I'm just printing that argument. So let's run this. So we should get that argument as well. And you can see that the argument that we had passed was cancelled, and we are getting the cancelled here, that before logger with argument cancelled. So this way you can see that we just define that whatever the input parameters are there, we can access those input parameters at the join points and we can do any operation. So we just logged it like whatever we had to do to log. Now we can also access the return type as well. What is the return type? So let me change a method. Let me add a method. Okay, public int quantity, simple quantity. I've just created a simple method which defines the quantity and it's returning value 2. So whatever has been written over here, if we want to access that, we can access using the after returning annotation. So let's go to the logging aspect. Let's create one more method, public void after returning and I can just sys out after returning. Okay, now for this we need to define a point cut, right? So what I'll do, I'll just define public void after returning, hope the spelling is correct, after returning point cut, and I'll just mention this is a point cut, and point cut is execution, and execution is for any return type from demo dot shopping cart dot quantity method, and I'll just keep double dot. So if we change the input variables also in the future, this will work. So this is a point cut where we have to execute, and we want to get the input variable as well. So the input variable, suppose I can say it's a type of string, right? And I can say it's a return value. Now how I will get the values over here? So here I need to define after returning, and here at which point cut I need to call this. So I can define point cut equals to, the point cut name is after returning point cut. This is what we created, right? So I'll just mention this over here, after returning point cut. This place I want to call this. Now I need to define the return value as well. So what is the return value? Returning. And what it is returning to? It is returning to the input variable that I have defined over here. So it will return the value to this variable, and we can access that variable over here. Hope this is clear. We just created the point cut over here. That point cut defines that this point cut has to be executed where? At the quantity method of the shopping cart, and this is the execution that I want for that. So I just define that after returning whatever has been returned from here, after returning 2, this has to be called. So I just define this after returning point cut, this will be called. And what will be the return value? That returning value should be coming to this retval variable that is been passed into the input variable. And here if I say after returning plus return value, so I should get to over here. Simple, right? So similarly we can also define for the after throwing as well, where if there is any exception we can get the exception and we can work for that particular exception in this aspect. So this was just a quick intro about the Aspect-J and how we can use it with the Spring framework. And there are a lot of different things that we can do, like for all the different types of packages and for all the different types of methods that we can define, and how those will be executed we can define using the point cuts. So this is all the basics and foundation of the Aspect-J. If you want to learn more, I will just link the documentation for it. In one page everything is defined there, and it's very easy to understand. After this video you will be able to understand that very easily. Start with the basics of a theory first, and then we'll move ahead with the application itself. So we will learn what is Spring and what is Spring Boot framework, and why we need a Spring Boot at the first place. After that we will see how to create a REST APIs using the Spring Boot framework. We will take one of the example, and with that example we will try to create all the REST API endpoints like get data, delete data, update data, save data, get a particular data. So all those endpoints we'll try to create. After that we will try to add the logging in Spring Boot. After that we will try to add the particular configurations in the configuration files. After that we will try to add the exception handling in the Spring Boot. We'll see how we can do the exception handling and all those stuffs. After that we will implement the unit testing for all the layers. So whatever layers we create, like controller layer, service layer, database layer, for all those layers we will implement the unit testing using the JUnit and Mockito. We will do all this using the in-memory H2 database. And after that, once you are comfortable with any of the database, then we will convert that in-memory H2 database to actual SQL database. So we'll be using MySQL database. So we will save all the data in our database. After that we will see how to get a particular values from the configuration files, whatever data or whatever configurations you can add in the properties file, how to fetch all those data. So we will also see how to implement metrics for your Spring Boot application, how you can monitor your application and how you can deploy your application to production. We will also see what are the different ways we can deploy Spring Boot application in our servers. So this is going to be a pretty advanced and long tutorial, so stick around till the end to learn everything in detail. I suggest you to practice alongside what I teach you for each and every topics, so you will get more hands-on experience for all the topics that we cover in this tutorial. So this is all about the different concepts and topics that we are going to cover in this particular tutorial. This is going to be very fun and very interactive video, so watch till the end and learn Spring Boot framework. Now firstly, let's see what is Spring and Spring Boot. So Spring is a Java framework built to create an enterprise ready application. So when you create a Java application, there are a lot more things that you have to do, a lot of configurations, a lot of property additions and lot of technologies, or a lot of packages and a lot of modules and jar files that you need to add to create your applications. Now Spring is a framework that allows us as a Java developer to do a lot of things. There are a lot of modules available for different kind of stuff that we can use as a part of Spring framework. There is Spring Core, Spring MVC, Spring Web, Spring Batch, Spring Data, Spring Data JPA. There are a lot of stuffs available in the Spring framework. We can use all those stuffs for our different activities. So we can only concentrate about the actual coding that we have to do. But when you're creating a Spring application, there is a lot of configuration that you have to do, right? If you're working with Spring framework and you want to include Hibernate, then you have to do the configurations for that. If you want to include any caching mechanism, then you have to do configurations for that. If you want to use any messaging queue, you have to do the configurations for that as well. So as a Java developer, as a Spring user, you have to do a lot of configurations to get ready with your application. After that, once you create your application, you have to deploy your application to any of the application server or web server. So there are a lot of moving parts when you are working with the Java applications. So Spring framework makes it easy for us to create all the application, but there is a lot of configuration that we have to do. So with this in mind, Spring developers thought of, okay, let's create something easier so all the developers can really concentrate on their actual work, only concentrate on the convention, not the configuration part. So for that, they created the Spring Boot. Now what is Spring Boot? Spring Boot is just the extension of a Spring framework. It's not a different framework. Spring Boot itself uses the Spring framework internally. It's just the extension layer for our Spring framework. Now Spring Boot provides key benefits for use for a Java developer. Firstly, the main thing is rapid application development. Spring Boot provides us to do the rapid application development. So whatever application that we want to create, we can create using Spring Boot very easily. The other thing is managing the dependencies. When you're working with the Spring framework also, at that time also, you have to add a lot of dependencies that you are using for your application. Spring Boot provides a way to group all those dependencies into a different starter templates. So Spring Boot provides different starter templates that includes all the dependencies that are required to do that particular task. So suppose if you want to work with the JDBC, then there is a Spring Boot starter JDBC template available that will include all the dependencies required to do that particular thing. If you want to work with the JPA, there is a Spring Boot starter JPA template available that will include all the dependencies required to do that particular task. There is a Spring Boot starter test available to do all our Spring Boot unit testing using the JUnit and Mockito. So there are a lot of different templates available that we can directly use as a starter template and we can directly work with it. The other thing Spring Boot provide is the auto configuration. So whenever we implement any of the things, we have to do the configuration for all those stuffs. Suppose if we implement Hibernate, we have to do the Hibernate configuration. Suppose we implement any messaging queue, we have to do the configuration for that messaging queue. If we implement any of the other libraries, there might be one or the other configurations that we have to do to work with the Spring framework. What Spring Boot does is the auto configuration for all those dependencies, all those libraries that we can use. So if you want to implement Hibernate, just add the Hibernate dependencies using the Spring Boot starter. All those configurations will be added automatically using the Spring Boot auto configure template over here. So that's a really good benefit for all the developers here. The other benefit that I like is the embedded servers. So if you see the traditional way of deploying the Java application is like you create the application, you create the WAR files of your entire application, and you deploy that WAR file in any of the application server or the web server, either JBoss, Tomcat or WebSphere or anything. You will deploy your WAR file to that particular server. But with Spring Boot, that particular server will be embedded to that particular entire application. So we won't be creating the WAR file of our application, we will be creating the jar file and in that particular jar file our server will be embedded, so we can directly run that jar file in any of the environment, so it's always production ready. So there are a lot more benefits to work with the Spring Boot applications, and the main thing is market is moving towards the microservices architecture rather than creating the monolith. So to create all the microservices using Java, Spring Boot is the default option. So now with this, it is pretty much clear that Spring Boot is the way to go. Now whenever we talk about the Spring framework or Spring Boot, dependency injection is the topic that everyone discuss, right? So let's understand why dependency injection is so hype over here. So if you take any of the programming languages or any of the frameworks for that particular programming languages, dependency injection pattern is a default way they will go for creating the different objects in the application. Now why that? Now if we take the traditional example, you create any of the class in your Java application, suppose student. Now to create the object of that student, what you will do? Student as equals to new student. So that means you yourself is creating the object of that particular class over here. And when there are a lot of hundreds and thousands of classes created and all those classes are interrelated to each other, then it's not a good idea to use that approach to create the class manually. So in this type of scenarios, inversion of controls comes into picture. What is inversion of control? Inversion of control is nothing but to give the control from yourself as a developer to the framework that you are using. So suppose if you are using Spring framework, that means we are giving the control to Spring to create the object for us. We will just tell the Spring, okay, you are the boss, you create the object for me, I'll just directly use it. So that's the inversion of control. We gave the control to Spring. Now to implement that thing, dependency injection is the pattern that we use. Dependency injection means, suppose you have created one of the class that is student, and in that particular class there is another class that is subject available. So you don't have to create that particular object for that. Dependency injection pattern will create that particular object for you whenever you want. So what will happen is when the Spring Boot application start, it have the factory that will create all the objects or all the beans of your application. So suppose if you have hundreds and thousands of classes in your application, all those particular classes object will be created when that particular Spring Boot context is started, and all those particular beans will be stored in one of the Spring's container. And whenever you want that particular bean or particular object, you will tell, okay Spring, I want this particular class, and Spring will give you directly. You don't have to create the object. Spring already has all the objects, you can directly use it. So this is very important part to understand. When we do the demo, we'll be using it everywhere. So at that time I will show you how to do this, but this is the theoretical part that you should understand what is IOC and what is dependency injection. So this is the concept in which everything will be working. So this is all about inversion of control and dependency injection in Spring framework. Now let's go ahead and start our applications. So Spring Boot provides us one tool to create the bare minimum or bare bone Spring Boot applications, and on that we can create our applications. So let's see what it is. It's called Spring Initializer. So let's go to that tool. If you go to start.spring.io over here, I'll link that into the description below so you can check this out. So with this particular tool, we can create the bare bone Spring Boot project. So here you can see that there are different things available over here. Here you can see that project information. You can create the Maven project or you can create the Gradle project. So these are the two project build tools available, Maven and Gradle. I'll be choosing the Maven over here, and you can see that you can choose any of the language over here. There is an option for Java, Kotlin and Groovy. We'll go ahead with the Java over here. And here you can see that you can choose the different Spring Boot versions available over here. Here you can see that different snapshot versions available, release candidate versions available. There will be different M1, M2, M3. That means a milestone versions available. I suggest you to always go ahead with the latest stable version available. Currently it's 2.4.5. Whenever you're watching this video, whatever the latest version available, you can select that particular version over here. So I'll be just selecting 2.4.5 over here. And if you go to the bottom over here, you can see the different packaging type is available. It's jar available and WAR file available. We'll always go ahead with the jar file. And at the below, you can select the Java version. Whichever Java version is available, you can select. I have Java 11 installed in my machine, so I'll go ahead with the Java 11 over here. You can see that you have to add the different project metadata over here. Here you can see that you have to add the group, artifact, a project name, project description, and your bees package over here. So let's go ahead and give this information. I'll just give com dot daily code buffer, com.daily code buffer over here, and artifact I'll give as Spring Boot tutorial. The name of the project is Spring Boot tutorial. Description is demo project for Spring Boot. That's fine. And here I will change the package name as Spring Boot.tutorial. So that's it. Now if you see over here, you can add the different dependencies over here. So as we will be creating the REST APIs in this particular application, Spring Web is the base dependencies that we need to add. So if you click on the add dependencies over here, you can see there are a lot of dependencies available. Yeah, you can search for it and you can add multiple over here. So we'll search for the web over here. Here you can see that Spring Web, build web, including RESTful application using Spring MVC, uses Apache Tomcat as the default embedded container. So when we add this Spring Web in our project, it will add all the default libraries that is needed to create our Spring Web application. So let's add this over here. We can add multiple over here as well. If you go ahead and click Ctrl B, you can see that there are shortcuts available. You can use all those things. Let me add over here. So currently we'll be using the H2 in-memory database over here. So if you don't have any database installed in your application, then also you can follow along the tutorial. So let's add that H2 in-memory database for now, and later when you are comfortable with the Spring Boot application, and then you can go ahead, install any of the database and you can connect that database. So currently let's add the H2 database. So you can see this is the H2 database, provides a fast in-memory database that supports JDBC API and R2DBC access with a small 2 MB footprint. Supports embedded and server modes as well as browser-based console application. So we'll be using this browser-based console application for this H2 database. So let's add this over here. Now you can see that we added all those particular informations. We added all the dependencies that we want to start our application. And if you click the explore button over here, you can see that this is your entire project. If you see this is the pom.xml file, as we have created the Maven project over here. And here you can see that this is the parent available. Okay, this is the Spring Boot startup parent and version information over here. And these are all the project metadata that you added over there, and these are the dependencies that you added Spring Web dependency, and we added H2 database dependency, and Spring Boot starter is the default dependency added for our unit testing. So this is the particular pom.xml file, and if you go to the src folder over here, this is the entire folder structure. If you see src main java com.daily code buffer.springboot.tutorial, this is our default package that we created. And this is the base file Spring Boot tutorial application.java that is created. This is the main application file. With this, our application will start. And here you can see that we have resources folder where we have our application.properties. We have test folder for our unit testing. So this is the entire project structure that we will be getting it. Let's close this. We can generate the project from here, and if you want to share this project with anyone with all the dependencies and all this particular information added, then you can click on share, and with this particular link everything will be added with by default values, whatever you added over here. So if you want to share with anyone, this is the great tool to share those particular project details as well. So this is all about the Spring Initializer project. Let's generate the project and then we'll open in any of the IDs available. So let's generate it. And here you can see that the project is generated. So this is the project that we downloaded over here. Let me just extract it. Now we can open this particular project in any of the IDEs of your particular choice. You can use IntelliJ IDEA, you can use STS that is built on Eclipse, you can use Eclipse itself, you can use VS Code, you can use any of the editor as well. There are a lot of different plugins available for all the different editors. You can add those plugins and it will be very useful for the Java applications as well. Nowadays I really like to work with VS Code as well with the different plugins available for Spring Boot applications. But today we will be working with the IntelliJ IDEA. There is an IntelliJ IDEA community edition that is free of cost that you can download. I will add the link in the description below for you to check that out. I'll also add the link for the STS for you to download. So let's open the project in IntelliJ IDEA, and we'll also open the same project in STS and see how it works. So this is the project over here. Let me open the IntelliJ IDEA. And here, let me just open the project. I'll click on open. And here, my project is available. inside my G directory, Spring Boot tutorial. This is the project. Okay, so let me open this particular project. Plus the project. You can see that it is downloading all the Maven dependencies and indexing all the files. So once that is completed, you can see this is my project over here. This is my pom.xml file over here. And this is my source directory, main Java. This is my package and this is my main application file over here. And if you go to the resources folder, you can see static folder, templates folder, and this is my main application.properties file over here. Now let me show you how to open the same in STS also. Okay, let me just minimize it. Let me open the Spring Tool Suite. I'm creating the workspace over here. I'll launch it. Here we'll import the project, and our project is Maven. So I'll just go to Maven, existing Maven project. I'll browse the directory. It's over here, G directory, Spring Boot tutorial. Select folder, and here you can see that pom.xml file is been identified. So click on finish, and here you can see that this particular project is imported, and at the below you can see that all the Maven dependencies are getting downloaded over here. And here you can see that if you open, this is your main Spring Boot application.java file over here. You have all your property file as well. Now to run this particular application using STS, you can go to Spring Boot tutorial, right click on it and click on run as Spring Boot app over here. Okay, you can also do run as Java application to run from here. So this is how your application will run from Spring Tool Suite. If you go to IntelliJ IDEA, if you want to run the application, you can see that if you have opened Spring Boot tutorial application.java, which is the main file over here, you have the play button. You can directly click on it to run the application. Else you can go to the file over here, that is Spring Boot tutorial application, right click on it and click on run over here. After you start running, here you can see that the play button is over here. You can run from there as well. So this is how you can run your application using STS and IntelliJ IDEA. So we'll be using the IntelliJ IDEA only, but if you are using STS, you can open this way and you can run from here as well. There is another way to run from the command prompt as well. That also I'll show you in a bit. So let me just close this STS for now. Okay, but you should get an idea like how to work with it as well. So let me just close it, and here you can see that this is my application over here. So let's go through everything over here. So if you go to pom.xml file over here, so here in the Spring Initializer also we saw that we had different starters available. At the starting also we talked about different Spring Boot starters available that will have all the dependencies which are needed to run our application. So here you can see that this is our main parent for our Spring Boot, that says Spring Boot starter parent, and after that we have added couple of more starters. So we added Spring Web, that added this particular dependency, that is Spring Boot starter web and Spring Boot starter test dependencies, and we added the H2 database over here, and this is the Maven plugin over here. So let's go ahead and see what's available, which are the dependencies added to this particular Spring Boot starter web. So if you do control click over here, this particular pom.xml file will open over here, and here you can see that these are the different dependencies available. You can see that it has added Spring Boot starter, okay, Spring Boot starter JSON, Spring Boot starter Tomcat, Spring Web dependencies, Spring Web MVC dependencies. Okay, so these are all the dependencies available. If you open again Spring Boot starter Tomcat, and if you go down over here, you can see that for this Jakarta annotation API is available and Tomcat embedded core is available. Okay, so you can see that we don't have to add all these particular dependencies, all added with just one Spring MVC starter dependency. So this is the benefit of Spring Boot application. Now if you go to the Spring Boot starter test over here, so here you can see that it has added Spring Boot starter, Spring Boot test dependency, and you can see Spring Boot test auto configure dependency. So this particular Spring Boot test auto configure will allow Spring Boot application to auto configure all the particular configurations to run this particular test. So you can see that it also added JSON pass dependency, Jakarta, XML bind API, Aspect JCore, Hemcrest, JUnit Jupyter, Mockito, JSON Assert, Spring Core, Spring Test. So yeah, you can see that if we were not using Spring Boot, we have to add all these particular dependencies and we need to start our application. We need to configure everything. But here, everything is configured easily. So this was all about the Spring Boot starters, which are the different starters available. Now, if you come to this particular file, that is Spring Boot tutorial application, which has the main method, which is the starting point for our Spring Boot application. And here you can see that there is an annotation added, that is Spring Boot application. So this is a key annotation for our Spring Boot application. If you open this particular annotation, you can see that it has few of the main annotations. You can see that it's Spring Boot configuration, and you can see that enable auto configuration and component scan. So what all these particular annotations do? Here you can see that it has added Spring Boot configuration. So that means it tells the application that this is the main Spring Boot configuration file. So this particular Spring Boot application, this is the main Spring Boot configuration file, and it is also added enable auto configuration. So that means all the auto configurations for our application will be added to it. And suppose if we want some of the classes or some of the configurations to not add automatically, we can also exclude them. So suppose taking the example of an Hibernate, if you don't want to add the auto configuration for Hibernate, you can add the classes in this particular enable auto configuration annotation to exclude all those particular things. If you open this, you can see that in this enable auto configuration, there is an exclude class list. You can add all the different class that you want to exclude. And here you can see that there is a component scan available. So component scan, if you are already aware about this Spring application, component scan will scan all the components available in your Spring Boot application, and all those particular components will be added to the Spring container when the application is started. So by default, whatever the package is there, like com.dailycodebuffer.springboot.tutorial. So this is the default package added. So whatever the classes or whatever the objects available inside this particular package or the sub packages will be added to the Spring container. So if you're creating different packages, you have to add the component scan and you need to add the package information. So those particular packages will come to Spring Radar, and all those particular objects will be added to the Spring container when the application is starting. So we need to understand what this Spring Boot application annotation does. So these are the key things that has been added to the Spring Boot annotation. And the Spring Boot application.run method starts our application. Okay, and this is the class that is already passed. Like this is the main configuration class that should be running over here. Now we can run this application. Okay, nothing will happen, but it will be running. So if you start the application over here, run Spring Boot application, you can see that it started running. Okay, you can see that the application started running. Here you can see that my application is running on Tomcat with port 8080 over here. Okay, the Apache Tomcat is Apache Tomcat 9 and it started in 2.335 seconds. Okay, so my application is running on Tomcat now. If I go to the browser and if I hit localhost 8080 over here, you can see that we are getting the white label error page, that is a fallback page. Okay, because we have not created any of the APIs now, so it's redirecting me to the blank page, blank error page for now. But my application is running on my embedded Tomcat. So you can see that we did nothing till now. Okay, we just opened the application in our IDE and we start, and entire application was deployed to our embedded Tomcat and everything was running. Now here let's create this sample REST API over here. Okay, so to start with, what we will do, we will create one of the package over here. Let's create one package. We will say as a controller, and inside this particular controller package we will create one controller. So we'll just say hello controller. This is my controller over here. Now we have to create a simple basic API. So now we already talk about the component scan and inversion of control and dependency injection and everything. So to make this particular class as a component of a Spring, so that whenever the application is started, this particular class is added to the Spring container. For that we need to add the @component annotation for this particular class that we created. So now this particular class will be in the Spring's Radar, so that whenever the application context starts, this particular class that we created new will be added to our Spring container. So whenever we need this class, Spring can give us. But technically this hello controller is not a simple component, right? It's a controller, it's a resource. So we can use a different annotations that is available, that is called controller. Now this particular controller, when you add this particular controller, it's a stereotype annotations. That means it tells us directly, okay, this particular hello controller is been added the @controller annotation. That means this is the controller by default. Now when you open this particular @controller, you can see that @component is added. So that means this will be behaved as a component by default. So that's a good thing over here, right? Because we have different components for different types of classes that we create. Currently we are creating the RESTful APIs over here. So that means my controller is still has to be REST controller, right? Not a simple controller. So for that also we have the annotations. Okay. So instead of controller, we can use REST controller over here. So this particular, when we add REST controller over here, it defines two things. It will tell, okay, this is a particular controller and as a component, plus it will tell that it will return always a response body. So if you open this, here you can see that it will always return the response body, because our REST APIs will always return some of the data. It won't return any of the JSP pages or anything, because we won't be working with all the JSPs. It's old technology. Let's use the new technology. So instead of controller, we defined, okay, this particular controller is my REST controller. So whatever the things I will be doing in this particular class, that all will be my REST endpoints. So I'm just removing the unused imports. For here in the IntelliJ IDE, I can use Ctrl-Alt-O to remove all the unused imports. Okay. Now let me create one of the methods over here. Okay. I'll just say public string hello world. Okay. And this particular hello world will return welcome to daily code buffer. Now what I want to do is I want to serve this particular endpoint. Okay, whenever I hit that particular endpoint, I want this particular method to be executed. So for that, what I'll do request mapping. Okay, so whatever the request I want to execute, I'll map that request to this particular method. So for that, I will do request mapping over here, and I'll pass value as slash. Okay, so whenever I'll hit localhost colon 8080 slash, this particular method will be called, and here I'll define the method. So which type of particular method it is, it's get, post, port, delete, or whatever. So this will be my get request. So I'll say my request method is request method dot get over here. So what I did, I assigned one of the endpoint, that is slash, that is my default endpoint, to this particular method. That's a get request. So whenever we hit this particular endpoint, we will get this particular string in return. Okay, simple thing over here. One more thing, as we talked earlier, Spring Boot does all the auto configuration for us. But if you want to change any of the configuration, Spring allows us to do all those configuration using the application.properties file. So we can add all the different properties to change whatever configurations we want to change. By default, my application is running on port 8080. That's the default Tomcat container port. Okay, so that's the auto configuration done for me. But now I want to change that particular configuration. I want to run my application on port 8082. So for that, we can add the configuration in my application.properties file. So let's go to the application.properties file, and here I can change my server port. So the property is server.port over here. Okay, equals to 8082. So that's it. Now my application will run on port 8082. Really simple, right? Now you might be thinking, oh, there will be a lot of properties, and how I'll get to know, okay, which properties to change. There is an entire documentation available that Spring Boot team has provided, like which particular properties is for which particular thing. So I'll link that particular thing in the description below, that particular URL. So you can check that out, what all configurations are available and which particular properties is for which particular configuration. So it will be very easy for us to change all the configurations. So this is the default for my server port that I changed, server.port equals to 8082. Now let's run this application. I'll just click on run over here to run my application. Here you can see that my application has started. Now my application is running on port 8082 over here. You can see that. So if I go to my browser, if I change my port to 8082, and this is my default endpoint I added, and here you can see that I'm getting welcome to Daily Code Buffer. So my application is running. Cool, right? So this is the first Spring Boot application. Now if you come over here, you can see that this particular line is still verbose, right? Because you are adding the request mapping and you're telling, okay, this particular request should be of type get. So always there are different types of requests available, right? Like get, post, put, delete, options, trace, everything. But always to add that particular thing, it's a little bit verbose over here, right? So what we can do, instead of using this request mapping, there is a different annotations available that defines that particular mapping. So we want to use the get over here. We want to map this particular method to get. So rather than using request mapping and to add the method as a request method.get, we can directly use get mapping annotation. And I'll define, okay, this is my endpoint. So you can see that we removed the entire line and it's very simple now. So this particular method we can directly identify, okay, this is the get mapping for this particular URL. And if you open this get mapping over here, you can see that get mapping has this particular request mapping over here, and it says that method is equal to request body.get, which already we did earlier, right? Instead of that, we can simplify with @get mapping. If you want to do post mapping, you can do @post mapping. If you want to do delete mapping, you can do @delete mapping. So all these particular annotations are available. We can directly use it. So it's very easy to use. So for this, let's again start our application. Okay. But for now, I'll show you the different way. So Spring Boot have the different Maven goals also to run our Spring Boot application. If you see over here, Maven, you have the different Maven life cycles available. You can run any of the particular life cycles also. So if you want to run this particular application using the command line, there is one way to use the Spring Boot Maven goals over here. So if you go to the terminal over here, we are not running from the application, from the ID itself. If you go to the command prompt to this particular folder, and if you do mvn spring-boot colon run over here, so this particular spring-boot is the Maven goals, we can run over here. So here you can see that my application started now. Okay, it's the same thing. If I go back, if I do refresh, you can see that my application is running. So we saw the two ways to run our Spring Boot application. There is one more way to run the Spring Boot application, that how we will be running our Spring Boot application in production, that I'll show you at the last. So stick around till the last. Now to close this server, I'll just do Ctrl+C over here. Okay, yes. So whenever we are developing the applications, we need to do a lot of changes and we need to start our servers after our changes. We need to test everything. So to stop the server and start the server every time once we do the changes, that's a really tedious task. So for that, Spring Boot provides the Spring Boot DevTools dependency that we can add into our project, so that whenever there is a changes, Spring Boot will detect those changes and it will restart our application. Okay, so let's add that particular thing and let's see how it's working over here. So for that, we need to go to our pom.xml file to add that particular dependency. We will use the particular project that we had already created in the Spring Initializer to add that particular dependency. So let me add the DevTools dependency over here. Okay, and if I go to the explore path over here, and here you can see that this is the DevTools dependency added. So let me just grab this thing and add in the project over here. After this, I am adding the dependency. Okay, save it. Now we need to reload our Maven configuration. So here you can see that you can reload the Maven configuration from here, and here you can see that the configuration has been added over here. Now if you are working with the STS, this particular DevTools will start working for you by default. But for IntelliJ IDEA, we need to do couple of changes so that our IDE is supporting live reload functionality, live building functionality. Okay, because by default IntelliJ IDEA is coming by disabling all those particular functionality. So let's go ahead and add that particular thing. So if you do Ctrl+Shift+A over here, you can see you can search everything over here, and here you search for the registry over here. Okay, in this registry, search for the compiler.automake.allow.when app.running. Search for this and tick mark this, so this particular things will be enabled over here. So that's the one thing that you need to do the changes. After that, go to the file, go to settings over here, go to build execution deployment, go to compiler, and here you can see that enable this build project automatically. Okay, so these are the two settings that you need to add in the IntelliJ IDEA. Once this is done, you can run your server. So you can see that my server has started running now. And if I go to the home controller, this is what I should be getting. So here you can see that I'm getting welcome to Daily Code Buffer. Now if I do any changes over here, if I do some extra AAs over here, okay. And here you can see that if you wait for some times, this particular changes should reflect. Here you can see that it reflected the changes. You can see that condition evaluation unchanged. So we are not restarting the server. If we go again and if I hit refresh, you can see that my changes are reflecting over here. Okay, so that means my DevTools is working. So this is what you should add when you are developing your Spring Boot applications. It will save a lot of time for you guys. So this is all about Spring Boot DevTools dependency. Now let's see what we are going to build today over here. Okay, what application that we are going to build. So if I have created a diagram over here. So here you can see that we will be building the backend application only. That is the creation of the REST APIs. So here you can see that I've just added all the front-end technologies. So from all these particular technologies, we can call our RESTful APIs, right? So we can create our entire backend using the Spring Boot, and from the front-end, anything can call these APIs to create the entire end-to-end full stack application. So what we'll be doing is we will be working with one department entity. So we'll be creating one department. So for that particular department, we'll be adding the different REST APIs. We'll be creating one post API to save that particular department. To get all the departments, we'll be creating one of the API. To get a particular department, we'll be creating one API. We'll pass one of the IDs. So for that particular ID, we will be getting the data back. We'll create one of the API to delete that particular department. And we'll also create one of the APIs to update that particular department. When you pass any of the ID, like I've created 4 to 5 departments and I want to change one of the department, that is department ID 3, then we can pass 3 and we can pass the data. So that particular department will be updated. So we'll be creating bunch of APIs over here to work with the department entity over here. So this entire particular thing we will be adding in one of the department controller that we create. So that will be our controller layer to handle all our requests. After that, we'll be creating one service layer. Our service layer will be our business layer. So all the business logic that we want to add to handle our department will be adding in that particular business layer. Controller layer is just to get the particular request and get the response back. So it's just for the routing purpose. Your service layer will be the main business layer where you will be writing all your logic. And after that, from that particular service layer, you will be calling your data access layer or your repository layer. This particular layer will be responsible to interact with your database. So whatever database operations will be there, this particular layer will be handling all those particular database operations. And we'll be having one database also. So currently for starting, we'll be using the H2 in-memory database. But after that, once we create a few of the APIs, we will switch over to the MySQL database. So you will get the understanding also how you can switch the database as well using the configurations. So these are the different layers that we are going to create. We'll be working with one of the department entities as well. So for this particular repository layer, we'll be using the Spring Data JPA over here. Okay, so for Spring Data JPA, we need to add the particular dependencies as well. So we'll be adding that particular dependency also. And for the database, we are using the H2 in-memory database. So we'll be using the browser-based console. So we need to add the configurations to enable that particular console as well. And we can add all the different configurations also. So let's create that particular application now. We already added the H2 in-memory database dependency. If you go to the pom.xml file, okay, we already added H2 database over here. Now we need to add the JPA dependency. So let's go to the Spring Initializer and let's add the JPA dependency. Okay, Spring Data JPA. This persist data in SQL, stores with Java Persistent API using Spring Data and Hibernate. Let's go to the Explore. And here is your Spring Data JPA. Okay, I'll just copy paste over here. You can see that we are not adding the version information over here because whatever the Spring Boot parent version would be, all those particular versions will be the same. All those particular things will be based on the our parent Spring Boot version. So here you can see that all the dependencies are added for my Spring Data JPA. So let's close this particular file. Now let's add the configuration for our H2 in-memory database. So we need to go to our application.properties file. And here we can add the configurations. So I'm just copy pasting all the properties over here and I'll explain you. Here you can see that we have added spring.h2.console.enabled equals to true. So we are enabling the web console using this particular property over here. Now after that, you can see that we are adding spring.datasource.url, that is jdbc:/h2.memory.dcbf. So this is what our database URL is. So we are using the H2 memory database and DCBF will be my database name. And after that we define spring.datasource.driver class name. So this is my driver, that is org.h2.driver. So we are using H2 driver over here. And these are my username and password, that is spring.datasource.username equals to SA and spring.datasource.password equals to password over here. And we define the JPA database platform as well, that we are using H2 dialect over here for using our JPA data source platform. So with this particular properties, our entire H2 database is configured for our JPA in Hibernate. And we also enable the H2 console. So let me just start the application and I'll show you our database as well. Okay. Let me just start this. So here you can see that once we added this particular configuration, that is JPA, here you can see that Hikari connection pool has been added. Okay. So all this particular, you can see that JPA entity manager factory has been added. Internally it is using Hikari connection pool to maintain all the database connections. So if I go to my browser now, and this is my application, and here if I do /h2 console, over here my H2 console will open. Okay, here you can see that this is my H2 console over here. This all the details are pre-populated. You can see that your driver class name, your JDBC URL, whichever we gave over here. Okay, everything is populated. If not, you can copy paste this information and you can add over here. Here you can see that your username is also populated, that is SA, and your password is this password. So you can add this particular password over here, test the connection. You can see that the connection is successful. So after that you can connect also. So here you can see that you are connected to your H2 console, and you can see that this is my schema, this is my database. Currently there is no table created for it. Now let's go ahead and create the department entity and create all the layers, and let's start working on it. And here you can see that we have created one of the packages. So let's go ahead and create the different packages for it now. So I'll go ahead and create. So the first package I'll create is the entity package. Okay, to create my entities. Then I will create the service package for our service layer. Then I will create repository package for our data access or repository layer. Cool. Now in this entity, we will create our department entity. So let me go ahead and create new Java class, and I'll say as a department over here. Inside this particular department, let's create few of the properties. So I'll just say private long department ID, private string, department name, private string, department address, private string, department code over here. So these are the different properties that I have added over here. Now let's create the getter setters. In the IntelliJ IDEA, you can use Alt Insert to create the different generators. So I'll just use getters and setters over here. I'll select all the properties, click OK to generate all the getter setters for it. Now I'll also use the same Alt Insert to create the constructor over here with all the fields. Okay, this constructor with all the fields, and I also create the default constructor as well. Constructor, default constructor, and I'll also create toString method over here. Cool, right? So this is the entity that we created. So now to make this particular class as an entity so that it can interact with our database using the JPA, we need to annotate this particular class with @entity over here using the javax.persistent.entity package over here. So now this particular department can interact with my database. Now as in the relational database, all the tables will have one of the primary key. So for this particular entity also, we need to create one. So my department ID will be my primary key. So to make that primary key, I need to annotate with @ID over here. Now how you will be generating your primary key, that also you can define over here. So here I'll define generated value status equals to generation type auto. So this is my entity created over here. Now for this particular, we need to create the controller now. So I'll go to the controller package and I'll create the new controller that will say department controller. As we saw in the particular home controller, we will annotate this particular department controller as REST controller. So this will be behaved as a REST controller and we can create the REST APIs over here. Now we have to create our services and repositories as well. So here we'll go with the standard practice over here. So we will create the interface for our service and we will create the class implementing that particular service, because one service can have multiple implementation as well. So we'll go with the same approach. We'll create the interface and we will add the implementation for the service as well. And for the repository also, we will create the interface for it. So let's go ahead and create the interface, that is new Java class. I'll select the interface over here and I'll say department service. This is my interface over here. Now I'll go ahead and create the implementation class for it. I'll say department service implementation, that is IMPL class. And I'll say this particular class will implement department service. And for this particular department service implementation, I will annotate this with @service. So we can know this is a service implementation for it. And here you can see that it also has the component source. This will be in the Springs Radar. And if we go to the repository also, we can create the interface, that is department repository, which is an interface. And we will annotate this particular interface with @repository. Now for this particular department repository, we won't be creating the concrete implementation class. Rather, we'll be extending the JPA repository itself, because JPA repository gives us a lot of different methods that we can use directly for interacting for our entities with the database. So let me just show you how to do that. I'll just use extends JPA repository over here. Okay, you can see the first one, JPA repository. And for this particular JPA repository, you need to pass your entity. So that is my department entity. And you also need to pass what's your primary key type. So my primary key type is long. So if I go to the JPA repository over here, you can see that this particular JPA repository extends paging and sorting repository and query by example executor. And if I go inside this also, you can see that it is extending CRUD repository. So we will be getting all those particular methods that are already been created for it. You can see that we're getting find all method. Okay. And here you can see that find all by ID, save all, flush, save and flush, delete in batch. All those particular methods are already created. So we don't have to create all this particular implementation. We can directly use this particular JPA repository for entire implementation itself. So I'll show you how easy it is. Okay. So here you can see that we created all the particular different class, that is my department controller, my department service and department service implementation, and my department repository also, which is extending JPA repository. And for all this particular classes and interface, we have added either repository or either @service or either @REST controller, which are the default annotations, which is adding @component for all our classes. So that means all the classes that we already created are in the radar of Spring now. So whenever the Spring application starts, all these particular objects will be created and will be added to our Spring container. So whenever we want, we can tell Spring that, okay, I want this particular class, so we can use it directly. Now let's go ahead and create the methods for our controller. So let's go to the department controller, and here I will create first method, that is to save the department over here. So let's create the method. What I'll do, I'll create the public method that returns the department object which is created, and I'll say the method as save department. And this is my method over here, and I will map to post mapping over here. And I need to call this particular post with /departments. So this is a simple mapping that I already did over here. Now what I want to do is, as I'm creating the REST API using the post mapping, that is the post request that I'll do from any of the REST client, I'll be passing the request body as well. So that will be the entire JSON object that I'll be passing in. So what I want that entire JSON object to be coming over here and to convert that particular entire JSON object to my entity, that is the department entity. So first let me define that what I want as an input. So I'll just say I want my department over here. Now whatever the JSON data that you are passing has to be converted to this particular department. So for that, what we'll do, we will add request body annotation. So we are telling Spring that whatever the data you are getting as a request body, okay, whatever JSON you are getting, get that particular JSON and convert that particular JSON to my department object over here. It's a simple thing. Without Spring and Spring Boot, what you have to do is you have to take that entire request body from the request HTTP request that you are getting, get that particular request, and using the object mapper, any of the Jackson or JSON, you have to convert that particular JSON object to the particular Java object. So that's all the steps that you have to do manually. But with this particular annotation, Spring is doing that for us. So with this particular one annotation, we are getting entire JSON object to my department object over here. Now I want to save this. Okay. So now what we have to do is we have to call this service layer to pass this data. And from that service layer, we'll do the business logic. And after doing that business logic, we can call the repository layer to save that particular data over here. Currently, we don't have anything to do. We can directly save it, but still we'll go ahead with the approach over here. So what we can do over here is we can do department service equals to new department service implementation over here. Okay, simple. We are creating the object over here. But why? Right? Because we are already using Spring over here. Spring knows that we already have that particular department service and department service implementation class and interface already created. And Spring also knows that, okay, this particular class I have in my Spring container. So whenever someone asks, I can directly provide that particular object that is already created. Why user have to create that particular object by their own? So this is what we are doing over here, right? We are creating the object with this particular new keyword. So we are taking the control back. I don't want that. So what I'll do, I'll just remove it. I don't want to create the object this way. What I want to do is, in this particular class layer, I am defining that this is the particular object that I want. I want the department service over here. But still Spring is dumb, doesn't understand. So we need to tell that, okay, this is a particular department service and I want it from you. So for that I will define AutoWire. That means AutoWire the particular object that you have in your Spring container to this particular reference that I have created. So that object will be attached, auto-wired to this particular reference that we created. So now it's simple, right? We use the dependency injection and inversion control from the Spring's functionality. Okay, we are not creating any of the object now. Spring has the object. We told them I want that object with the auto-wired. That auto-wired will wire that particular object with the reference that I created. Now there are two types of auto-wiring or two types of dependency injection that we can do in the Spring, that is constructor based and the setter based, and here we are using the property based. So we are just creating one of the property and we are directly using the AutoWire to attach that particular object to my property. You can also go ahead with the constructor based. You can create the constructor, you can pass this particular department service in the constructor, and you can create the object as well. So there are different ways you can do the dependency injection as well over here in Spring. Now here what we can do is we can create, we'll just return department service dot, we'll give the same name over here, and we'll pass the department object that we are getting. Okay, over here. Now there is no save department method created in either of the service or service implementation, so we have to create it. So let's create it. Here in IntelliJ IDEA, if you do alt enter over here, you can see that it is giving the option to resolve this particular error. So it is saying that create method save department in department service interface. So let's go ahead and create it. So here you can see that this particular method is created over here, and I'll say it as a public method over here. And here you can see that it has a problem for this. So that means whatever the service implementation class for this department service is there, we have to go ahead and implement that as well. So let's go ahead, we'll do the alter insert and we'll say implement methods available. So here you can see that this particular method is implemented over here. Now it's still returning null over here. So what we need to do over here is we need to get the reference of the department repository over here. So we'll do the same thing what we did in the controller layer. We'll just do private department repository. We'll create the reference to it and we'll do auto wire. So that means this particular object will be attached to this particular reference. Now we can call department repository dot. Here you can see that there are a lot of different methods available from the JPA repository that we have extended. Okay, so here I'm looking for a save method. This is a save method which is taking the entity over here. So my entity is department. So I'll just pass this department and voila, that's done. So with this particular method, my department will save to my database over here. And here you can see that we have not created the table also. Spring Data JPA will create that particular table also for us. Okay, and whenever there is an update to it, that particular update JPA will do to our database as well. So now what we'll do, let's test it out. Okay, so now testing out, you can use any of the REST client you want. You can use Postman, Insomnia. You can, if you're using VS Code, you can use Thunder client as well. You can use curl as well. You can use HTTP Py as well. There are a lot of clients available. You can choose any of the one which you're comfortable with. Here I'll be using Insomnia for now. You can use Postman as well. That will be also okay over here. What we'll do is we can start the application. We can open the Insomnia as well, and we'll see what's happening in our database as well. So let's start the application. Here you can see that my application is started now. If I go to the H2 console over here, if I refresh, let me log in, and here you can see that particular department table is created, and department ID, department address, department code, and department name. These are the 4 entities that we created over here, properties, okay, the department. Cool, right? Now let's save the data. If I do over here run, you can see that there are no records available. So if I go to the Postman, let me create the new request over here. Okay, I'll say save department, which will be the post request, create it. And here I need to give the URL. I'll just give http://8082/departments over here. And in the body, I need to give the JSON data. So let me give the JSON data over here. So let me just copy paste the details over here, okay, from the department entity. So I want department name, I want department address, and I want department code as well. My department ID will be auto-generated, okay. So I'll just give my department name is IT, department address as say Bangalore, department code I'll say IT06. So this is my JSON data over here. This is my API with the post request. If I do send, you can see that it's 200. Okay, that means data is saved, and this is the data that we are receiving back. And you can see that department ID is created 1. If I go back over here and if I do run this particular query, you can see that this particular data has been saved over here. And if I save another data, CE is the department, computer engineering department, and I'll say C07, it's still in the Bangalore, and if I hit send, you can see that this particular record has been inserted and we have 2 records now. Okay, so my save functionality is working fine. Now you still have to remember that we are still working with the H2 in-memory database, so whenever we restart our application, we will be losing all our data. So now let's go back and work on the get APIs. Now here we will add one method that will allow us to get all the departments from the database. So let's create one of the method over here. We'll say public, and here as we need to get all the departments available in the database, we will use the list of departments. So I'll just say list of departments available, and I'll just say fetch department list over here. Okay, and here this will be the get mapping. Okay, so I'll just say get mapping of departments. Now from here we need to get the list of departments from the repository and send back. So I'll just use return department service dot fetch department list over here. We are not taking any input over here because we need to send all the data back. Okay, and this particular method we need to create in the service interface and service implementation as well. So click on alt insert, create method fetch department list in department service. Yes, and make it public. We'll go to the department service implementation class, alt insert, and implement this particular method. So this particular method list of department fetch department list will send the list over here, and instead of return null we will say department repository dot inside this department repository we have a method that is find all, that will get all the department as a list and will send back. Done. So this particular method will get all the departments available in our database. So let's run this. Over here we can see that our application is started. Let's go back to the Insomnia in the save department. Let's save the department. Okay, CE Bangalore C07. Let's save this, and I'll save also IT department IT06. It's in Bangalore. And I'll save one more department, that is electrical engineering. It's in Ahmedabad. And I'll say EEE01. And here you can see that we have added 3 records over here in our database. Okay, let's create new request. I'll say get department, and it's a get request. Okay, let me copy paste the URL from here. HTTPS localhost 8082/departments. That's what we have defined over here in the department controller. Okay, so we'll be using the same. This will be the get request. Now this particular request should return me 3 records. If I hit send over here, we can see that we are getting 3 records over here. So all the data we are getting from our database. Now this is to fetch all the data available in our database. Now what if we want to get a particular record based on the ID, that is a primary key, which is department ID over here. So let's go ahead and create one of the APIs where we will pass the ID of the department, and based on that ID we will be getting that particular record over here. So let's go to the IntelliJ IDEA, and here what I'll do in this controller layer, okay, I'll create one of the methods that is public, and here we need a particular department based on the ID. So I'll say department because I need that particular object only. I'll say fetch department by ID, and this will be again get mapping over here. I'll say it will be /departments. Now whenever we are calling this particular /departments, I want to pass a particular department ID for which I want to get the data. So that particular part will be dynamic because I can send any of the IDs over here. So that is called a path variable, right? Because what we'll be doing is we'll be doing localhost colon 8086 slash departments slash whatever ID we are adding. Okay, that's a path variable. So we can define as this way. So this is particular dynamic value that whatever ID we get, we have to get as a department ID. And we have to get this particular ID what we define over here as an input parameter to our method as well. So what we'll define long department ID over here. Now we need to map this particular ID with this department ID. So for that we'll annotate this with path variable, and this path variable is ID over here. So this path variable ID, whatever defined over here, you need to give the same value over here, and this will be attached to this particular department ID. Now we can find this particular department based on this ID. So let's create the method over here. We'll say return department service dot fetch department by ID, and here I will pass department ID over here. Again, I need to create this particular method in service class. So alt enter and create method fetch department by ID in department service. I'll make this as a public method, and I'll go to the department service implementation, implement methods, and I will implement this fetch department by ID method over here. We need to use this department ID as an input parameter. So what I'll do, department repository dot find by ID. Okay, this is the method, and here you can see that it will return the optional of department, and it is taking long ID as the input variable. So I'll pass department ID, and here this entire particular thing, this find by ID, will return the optional. So to get the value of department, we will use get over here to get that particular department. Now let's go to the Insomnia and test this. Okay, no data because we need to add the data back again. So let's go ahead and add the data. So we'll save the first record, we'll save the another record, that is IT department ID 06. I'll add send. Okay, if I go to the get department, and here you can see that I'm getting two records over here. But suppose if I want to get a particular record, suppose department ID 2, I want IT department. So with the get request with the same URL, we did extra thing over here is we added the ID over here, that is a dynamic ID that we can pass. So let's pass the 2 over here, and if we hit send, we should be able to get this particular IT department. Here you can see that I'm able to get this particular IT department over here. So we did get all and get by ID. Now let's implement the delete functionality. So let's go to the IntelliJ IDEA, and in this particular controller, let's create one more API over here. Okay, I'll say public string delete department by ID over here. Okay, and this is the particular method, and here what we'll do, we will do the delete mapping over here. Okay, and with this delete mapping, I will add the same API over here. Okay, same URL with slash department slash ID, whatever we pass, that particular object I want to delete. And here I will add long of department ID, and this should be again path variable. The same information that we add in the get mapping in the previous method, the same information we are adding over here. As we are passing string over here, what we have to do is, if everything is successful, we can pass return department deleted successfully, and let's call the department service method as well. We'll call department service dot, we'll create this particular method, that is delete department by ID, and for this we will call, or we'll pass department ID over here. We need to create this particular method in the service as well. So let's create So let's create this particular method. Sorry, we need to pass department service over here, right? So now we have a value that is create method delete department by id in department service. Okay, so let's create the method. This is of type void. We'll pass public over here. Let's go to the department service implementation class and let's implement this method. And here what we'll do, we'll call department repository dot delete by id over here. Okay, and here I'll pass department id. Okay, this particular department by id is returning void over here, so that's why we are not returning directly, we are returning the string over here. So whatever the id we will be passing, that particular thing should be deleted. So let's check it again. We'll go to the Insomnia, we'll go to the save department API. Let's create this API, that is IT department is created. Let's create the C department, C07, send over here, C is created. The get mapping if we can do, okay, that particular record is created. And if I check for all, you can see that we are getting all the departments. Now let's create the new request for the delete one. New request delete department. We'll use the same API, right? So I'll just copy paste it, and this particular get should be delete over here. And suppose I want to delete this particular C department over here. Okay, so I'll pass 2 over here and I'll hit on send. Here you can see that we are getting department deleted successfully. And if I do the get operation over here again, you can see that we are getting only one record over here. So that means our delete functionality is working perfectly fine. Now let's go ahead and implement the update functionality. So in the update, whatever the ID that you pass, so /department/ID, whatever particular update operation you want to do, plus which particular data, which particular new data that you want to update, and that also will pass as a body over here. So let's go ahead and implement that. In the IntelliJ IDEA, we'll create a new method. We'll go to the controller again. Let's create the new method over here. We'll create public and we'll return the department object over here. Okay, and we'll say update department, and this particular will say put mapping. Put is used for update, and this API would be the same I'll using. Okay, now here we have to add two things. We need to take the path variable also, that is ID over here, plus we need to take the request body as well. So whatever the path variable, whatever the ID that we get for that particular record, if it's present in the database, we have to update with the new values that we have. So let's do that. What I want is, I want long department ID and I want department object as well, but my department object would be request body and my department ID would be path variable with ID over here. Two things I have defined over here. Now we need to call the service layer. So let's call the service layer. We'll say return department service dot, we'll create the method that is update department only, and in this particular method we will pass department ID and department, both the things. And let's create this particular method in the service class as well. We'll create the public method. Let's go to the service implementation class and let's implement this particular method. This is the method update department, which is taking department ID and department as the input parameter. So here what we'll be doing is, we will first get the department which is already available in the database, get that particular object, and then whatever the changes that we have done in this particular department, we will update with that particular value. So suppose after the 3 fields that you have, if you only change in one of the fields, we should only update that particular field, and we should check if the other fields are null, then we can skip it. So let's do that. We will do department from DB equals to department repository dot find by ID. We'll pass department ID dot get. Sorry, it should be find by ID. Okay, simple. Now once we get this particular department, we can check if any of the particular parameters are null. Then we can skip it. If there is any value, then we can update this DEP DB object over here. So what I'll do, if objects dot non null, I'll check department dot get department name and not blank dot equals ignore case department dot get department name. Then I'll say DEP DB dot set department name equals to department dot get department name. Simple, right? We are just checking if anything is not null and not blank, then only set the value, otherwise skip it. So let's copy this and set for the other entities as well, other properties as well. So department name is done. Then we'll go for get department code over here, department code and set department code. And here we'll go for get department address. So department address, I'll just copy paste it and set. So here you can see that we did the null checks and blank checks for all the three values. And after that I can say return department repository dot save department DB. So it's very simple over here. We took the value from the database, that is DEP DB over here, and whatever the input parameter that we got from the endpoint as a request body, we are checking the null checks and blank checks for all the values. Whichever are not null and not blank, that only we are updating to the database. Rest we are skipping it. And after at the end we were just calling the save method of a department repository. So that's it. So let's check it. We'll go to the Insomnia. First we'll save the value in the database. Okay. So here you can see that is the first record. Let me add the second record as well. IT06 send, and if I do get over here, you can see that I am having two records over here. Okay, so let's create new request for update. I'll create new request, update department, and then I'll change to put method JSON body create. Here I need to pass a JSON data. So let me just copy it from here, and I'll also copy the URL as well, and I'll go to update and I'll paste it. If I go to the get department, here you can see that for the second department 2, the department name is IT, the address is Ahmedabad, and department code is IT06. Okay, so for the second department ID we will do the changes. So I'll pass /2 over here, and instead of department name IT, I'll say information technology, and the rest of the things I am passing the same over here. Okay, so let's hit send over here, and here you can see that particular department name is updated for the second record over here. If you go to the H2 console also, we can see the same. Okay, let me just log in over here. And if I run it over here, you can see that we are having two records and the IT department is changed to information technology over here. And suppose if I remove this information over here and remove department code also, and just I'm telling that change the address of the second department. Okay, that means information technology to Bangalore. And if I hit send over here, you can see that only Bangalore updated, rest of the thing is everything same. If we check the database also, you can see everything is updating correctly. So we successfully implemented entire CRUD application, CRUD endpoints for our department service. We did get, get all, save, update and delete everything. Now let's see how we can add the different extra endpoints also. So now let's create one of the endpoints that will return the department based on the department name that we pass. So let's go to the IntelliJ IDEA again. Let's go to the controller, and here let's create the new endpoint. We will say public department, and I'll say fetch department by name. Okay, and here I will pass the get mapping over here, and inside this particular get mapping I will pass slash departments, and slash I'll say pass the name, and slash I'll say pass that particular name that you want to pass, and here I'll say string department name over here, and we need to bind this particular department name with the path variable that we have defined, that is name. So I'll just say path variable name over here. It's pretty simple over here. Okay, now let's go ahead and implement in the service and repository layer. We'll just say return department service dot fetch department by name. We'll pass the department name over here, and let's create this particular method in the service layer. Create method. We'll go to the service implementation and we'll implement this particular method, that is implement methods over here. Now for this particular fetching the data for department name, there is no default method available in the JPA repository. Okay, so that means we need to define one for us to use that. So let's go ahead and create one. Okay, let's go to the department repository. This is the interface. Let's create one method. We'll say public, which will return back the department. Now the naming convention is the main thing over here. What we need to do is we need to give find by, after that whatever the name of your entity is. So the name of my entity is department name over here. Okay, let's copy it. Let's go to the repository layer and paste it, and the naming convention should be this way: find by D capital, always in the camel casing. Okay, department name over here, and this department name should take string department name as the input parameter. That's it. So we don't have to do the implementation for it. With this particular naming convention, we should be able to get the data back. Let's go to the service IMPL and let's do return departments repository dot find by department name, and let's pass the department name over here. Simple, right? Now let's go ahead and check how it's working. Let's go to the Insomnia. Let's go to the save department and let's create the department over here. The first department is created. Let's create the second department. CE07 send. Two departments are created. Let's check in the get mapping. Two records we are getting over here. Now let's create one more request over here, department by name, and I'll do the mapping over here. What we have to pass is we have to pass department slash name slash the name of the department that you want. Suppose I want CE, then I need to pass the exact value that we have added to save the data. That is C in capital, need to pass C in capital. And if you hit send, you can see that you are getting the data back. So it's matching the data correctly. Now if you pass the C small over here, you can see that there is no data available because it is matching the exact value over here. Now how to make sure that you are getting the exact values? So let's implement that method as well so that you are getting the exact values. So what we will do is we'll go to the IntelliJ IDEA again, we'll go to the repository and let's create one more method that will return the department based on the department name and ignoring the case. So we will define ignore case. Simple. Okay, now we need to call this particular method from our service IMPL. Now let's check this again. Now let's go to the Insomnia. Let's go to save department. Let's save this C department. First record is saved. Let's save the IT department as well again. If you see the get departments, you are getting both the departments. And if you pass CE in capital over here, you can see that you are getting the data. But if you pass C in small also, you should be getting the data because we added the method for case insensitive. So whether it's in capital letters or in small letters, it should be able to match the records. So that's how we can implement the different JPA methods. Now you might be wondering how I'll be get to know like what are the different methods or what are the different method names that you want to give to get that particular records. So for that, let's check the documentation for that. I will link this particular URL in the description so you can check this out. But if you go over here you can see that these are the different keywords available, how you can use and how you can create the method names. So yeah, you can see that if you want to get the distinct records, you can use find distinct by whatever the value you want. Find distinct by last name. So suppose in our case it's department name, so we can pass find distinct by department name. And if you want to get the data based on multiple values, you can see we have here it's added and you can give the another value as well. And in the input parameters, you need to pass the two values. First input parameter will pass as a last name. The second input parameter will be passed as the first name over here. And the equivalent JPQL snippet, JPQL query, you can see it's this: select distinct, the table name, whatever the entity name is, where x dot last name equals to question mark 1 and x dot first name equal to question mark 2. So first and second property, it will pass this way. You can go for AND properties or is equals find by first name is whatever the particular value that you are passing. If you want to get the dates between the two dates that you pass, you can use find by start date between. So if you can pass two values, date 1, date 2, and you will get the records between that two dates available. If you want any value with less than, equal, greater than equal, all these particular things you can check over here. Based on this particular naming convention, if you follow, you will get the data. Now sometimes if you want to get the data and that data may be complex, the query may be complex, and you may not be able to achieve using this particular syntax to create those particular methods. So for those type of case, you can also go ahead with the JPQL. And if you are not able to go with the JPQL as well, at that time you can also go ahead with the native SQL queries also. So for those type of case, you just have to pass the @query annotation over here. So whatever we created the method over here, right? So that particular method that you create, suppose in our case, this is the method that we create, that is find department name ignore case. And if you are not able to get that particular, it's complex something, then you can annotate this particular method with @query over here, spring framework data.jpa.repository, and in this query you can pass your entire query over here. If it's JPQL query, just pass the JPQL query, and wherever the input parameter is there, you have to pass question mark 1 for the first parameter, question mark 2 for the second parameter. And if it's the native SQL query, then just pass the query over here, and there is a native query equals to true value available. So just pass this value, that native query equals to true. That means after that, this particular query, whatever you pass over here, SQL query, will be treated as the native query and you will get the data. So this is also you can use to get the data. Either directly use the method names. If not possible, go with the JPQL. That also, if you feel some difficulties in that, you can always go ahead with the SQL queries natively also. So this is the documentation for it. I will link that in the description below so you can check this out. There are a lot of things available and it's very easy to implement. Here you can see that it's the native query, right? It's done select queries, question mark 1 for the first value, question mark 1 for the second values. Okay, here you can see that it's defined like native query equals to true. So you can always get the data. Now here we added all the APIs over here. Okay, now what we'll do is we will add the validations for all our APIs that we have created. So what we can do over here is, suppose we have 3 to 4 fields that is coming as the input parameter for our APIs, right? To save the data or to update the data. And we can add the validations like, okay, I want my department name always to be available. Okay, without my department name, that particular JSON data, particular request body, that whatever we are getting from the client, that should be invalid. That should be bad request. So that means every time that particular thing should be available. we can add a lot more different types of validations when we are getting the data as the input as the JSON format to our APIs. So let's see how we can add those particular different validations. So all these particular validations we can add using the Hibernate validation. So for that, we need to add the dependency for it, and we need to annotate our entities to validate all our requests. So let's go ahead and do it. So we'll go to the pom.xml file and we need to add the dependency. So this is the Spring Boot starter validation over here. So let me just add it over here. You can see that Spring Boot starter validation. This is the plugins that we have added. Let me just do Maven install again over here. And with this particular dependency, if you go to this particular starter, here you can see that it is using Hibernate validator over here. Okay, so this particular thing that we are using over here to do our validations. Now how to add the validations? So suppose let's go to the department entity over here, and what I want is whenever I'm getting the data as an input from the JSON, I want my department name always, because my department name is very important. I want to save my department with my department ID auto generated and with the department name. If I don't have address and code, that's fine, but I should be having department name. So what I will do over here is I will add the annotations over here so that the validation can happen. So what I'll add the validation is not blank. Okay, here you can see that it is from the javax.validation.constraints package over here, and with this particular not blank, I will add the message over here, like what particular message I should display when this particular validation fails. So I'll just say please add department name. So this is the particular validation that I have added over here for this particular department name. Now if you go to the controller and in this particular post mapping, this is where that we are getting the data. So this is the place where we are getting the request body. Now whenever we are getting the request body over here, we need to validate that. So for that we will add @valid annotation over here. Okay, that is from javax.validation. So just add this. Okay, sorry. So add this annotation that is from the javax.validation over here. So now whenever the request is coming over here to save the data from the post mapping, that particular request, that JSON body as coming as a request body will be validated against the annotations that we have defined over here. There are a lot more different annotations available for the validations. So for now, let's test this out. Okay, so let's run this application, and my application is started. Let's go to the Insomnia, save department, and if I hit send over here, you can see that my data is saved. Now what if I am not passing this department name over here? Okay, and if I hit send, here you can see that we got the error, that is 400 bad request. And if you scroll down over here, you can see that we are getting the default message that is please add the department name. This is what we added over here, right? So that means this particular validation is happening. Okay, and you can see that we are getting all the different values, that is object name is department, field is department name, rejected value is null, so it was passed null, so this particular value got rejected. So there are a lot more different validations available. Okay, let's see that what are the different things available. There is not blank available. Suppose if you want to check the length, okay, and then you can add the length over here, and inside this you can pass max value, and you can pass min value over here. Okay, and you can also pass the message. You can check the size as well. In this size also you can pass the max value and min value over here. You can check for the email validation, that this is a particular email field over here. You can also check if this particular, if there is an integer value or long value. You can also check if that particular value is positive, that particular value is negative, or you can also check positive or 0. So positive and 0 is allowed with @ negative or 0. Negative and 0 value is allowed. If there is a date field, you can check that particular dates are future, or particular date is future or present. Similarly, you can check for the past dates and past or present also. So you can see that there are a lot more validations available, and for all this particular validation, either you can pass the regex. For the email, you can pass the regex expression to match that particular regex expression for email validation. For length size, you can pass min max values. For the different positive negative values, we can validate future dates, past date also we can validate. So these are all the different types of annotations we can use to validate our input request, that is JSON data. So you can check all this particular out, and you can add the annotations based on the fields that you have and based on the validations that you want to add for that particular fields. So we are just using not blank over here now, but these are a lot more that you can use. I'll just comment it out for now, and I will add the code in the GitHub, and I'll share the link with you so you can check this out. So these are all the different validations. Now what we can do is we can add the loggers in our application. So all the applications should have the loggers, right? Currently you can see that we have not added any of the loggers, but we can go ahead and add the loggers. It's very easy in Spring Boot. Currently we will just add the simple loggers over here, but that particular loggers can be extended to file based loggers. Like you can save that particular loggers in a particular file. You can add the rolling based file logging functionality, like for every day you can create the new files, or based on a particular size limit you can create the different files. All these particular configurations you can add using the application.properties file that we have. So you can check all those particular things. It's very easy. But for now, let's add the simple logger over here, and we'll see how we can add the logging over here. So Spring Boot comes with the SLF4j logging library within the system with all the Spring Boot starters available. So let's go ahead and use that. If you want, you can use a logback or log4j with SLF4j. So there are different libraries available. If you want to add those, you can add that particular libraries in the pom.xml file and you can use. But if you are directly using SLF4j, you don't have to add any of the libraries. Those are directly available and you can directly use it. So let's add in the department controller over here. So for the loggers, what we'll do is I will add the logger over here, that is private final logger class. Okay, this logger I'll be adding from the org.slf4j, the first one, and I'll say logger equals to logger factory dot get logger, and here we need to pass the class name, that is department controller dot class over here. So here you can see that this is a simple logger implementation that I added, that I'm using SLF4j implementation, and using from the logger factory I'm getting the get logger for the department controller class. Now suppose I want to log whenever the particular request comes to this particular save department. So what I can do, I can say logger object that I created, logger dot info, I'll say inside save department of department controller. Simple over here. Okay, so I'm just adding one of these particular loggers over here. Let me add the same for get departments also inside fetch department list of department controller. So similar types of logger you can add in all the particular service and repository layers, and these particular loggers will be helpful for debugging our applications, right? So it's just a simple logger that we have added. Let's restart the application. And now when we call the save department, hit on send, you can see that we got 200. Okay, and if you go over here, we also got the log as well. You can see that particular entire, which particular thread it was, which particular class it was, and what's the log message over here. So you can see that we are getting the logs as well. If you go to the get department and if I hit send, you can see that we got the logs for that also inside fetch department list of department controller. So we simply added the loggers over here. Okay, so logging is implemented over here. Now we can create the different policies how we want to aggregate the logs, either in the console, either in the file, either we want to create the rolling policies. All those different configurations we can add in the properties file. So if you go to the documentation, you will get everything, but this is how you should, or you will be implementing loggers in your Spring Boot application. Now, as we are working with the Java application, we tend to create a lot of POJOs, right? So we'll be creating the POJOs, we'll be creating the properties, and for all those properties, we'll be creating the getter setters, constructors, toString methods, and all those different things. Now, creating all those particular different things is easy, but your code is not looking good, right? Because if you see that particular example of our department also, for the particular 3 to 4 fields that we have created, for this particular 4 fields, we created getter setters, we created the all arguments constructor, that is constructor with all the arguments with the default arguments, toString methods. You can see that your code is around 82 lines, but at the end you just need this particular 4 fields over here. Now we should be getting rid of all those particular things, right? Because we don't need it. So for this particular thing, there is a library available that is called Lombok. Now Lombok allows us to remove the boilerplate code from our Java applications. So what we can do is we can remove all this particular getter setters and everything, and we can use Lombok, and that particular plugins will add all these particular methods at the time of compile time. When particular compilation happens, all those particular methods will be created. So we don't have to see in our code, but that will be available. So let's see how to implement that. So if you go to the Spring Initializer that we had already, right? This is a particular project that we had already opened. If you go to the add dependencies and if you search for the Lombok, here you can see that Java annotation library, which helps to reduce boilerplate code. Let's add this particular dependency. Go to the explore and copy paste the data from this particular pom.xml file. If you see over here, this is the particular dependency added. So let's copy paste this particular dependency, go to our pom.xml file, add this particular dependency. And once we add this particular dependency, we also need to tell the Maven plugin that we are using Lombok. So copy paste this also, okay? This entire plugin, this plugin we will copy paste. So we are excluding Lombok over here. Now once you add the Lombok, for your IDE to know that you are using Lombok, you have to add the plugins in your IDE. If you are using any of the IDEs, either IntelliJ IDEA or STS or Eclipse or VS Code, all those have this particular Lombok plugin. Just go to your plugin sections and search for it. I'll show you for the IntelliJ IDEA. If you search for the plugins over here, and if you search for Lombok, you can see that I've already installed, so it's coming over here. Okay, you can go ahead and install it. It will be available in all the IDEs. Now this particular thing is only required when for your development activities, but when you are running this particular application directly using the command line, that particular thing will compile and the particular jar file will be created. So it will work directly in your production servers as well. So there shouldn't be any worry about it. Now let's implement Lombok in our entities. So let's go to the department entity over here. Let's remove everything, all the getter setters, all the constructors, toString method, everything. Okay, simple. We have 4 fields over here, that is department ID, department name, address, and department code over here. Now to make this particular department to use Lombok, I just need to add @data. You can see that it is from the Lombok. So if you just add data over here, and if you open this annotation here, you can see that this particular data is equivalent to @getters, setters, required args constructor, toString, and equals and hash code. So all these particular methods will be created for us. So we don't have to add any getter setters and everything. And if you just want any getter setters, then you can just go ahead and use getters and setter. Okay, if you don't want setter, just remove it. Just the getters will be available. But for this particular entity, that is department, we need everything. So I'll just annotate with @data over here. Alongside all the getter setters, hash code, equals method, and toString methods, I want a default constructor as well, that is no args constructor. So there will be default constructor created with this. And if I add all args constructor, the constructor will be created with all the arguments. Now if I add @builder over here, okay, you can see with this particular builder, an entire builder pattern will be implemented for this particular department service. Now if you don't know what is builder pattern, that's fine, you don't have to worry about it for now, but just understand that if you want to implement this builder pattern with this particular @builder annotation, you can do it. In the later part of the video, I'll show you how we are using this particular builder pattern, so stay around for that. But we can add this particular annotation, so it will start working. Now if we run this application again, everything should work smoothly. No compilation error or nothing should be happening. So here you can see that our application has started successfully. And if we go around to save the data, we should be able to save. And if you go to the get department, we should be able to get the data as well. So everything is working smoothly. We just removed all the boilerplate code that we was available in our application. So this is a really good plugin that you should be using in your applications. So let's talk about the exception handling in Spring Boot. Now currently if you see our application, okay, let's take one of the example over here. We'll take the example of get department based on ID over here. If you go to the Insomnia, let me save one of the department. Okay, I've saved one of the departments. If I go to get department, and if I take this, I'm getting all the departments, and if I pass one over here and if I hit send, you can see that I'm getting that particular department. But if I pass any of the ID for which that department doesn't exist, you can see that I'm getting the error over here. And here you can see that this particular error response have a lot of values over here, right? Timestamp, status, error, trace, what is the entire stack trace over here. Okay, here you can see that there's a lot of details over here, right? And you can see that what was the message, no value present, what was the path, everything. But actually I don't want all these particular details, right? I want only particular relevant details to show as an error message. So whatever we want to send the data in the UI, we can send the data, and based on that particular error message and status code, we can handle all those particular stuffs in the UI. All these particular stack trace and everything, if we are logging in the backend, that's fine. But I don't need that particular things to pass in the UI. So let's see how we can handle such type of scenarios and how we can send the data back as the error response. So what we will do over here is,